Hey everyone, welcome back. Guys, just give me 2 minutes. I will join you guys back. Okay, I'll be back in 2 minutes. Oh, everyone, welcome back. Hi, I'm good guys. Thank you so much. I hope everybody's doing good. Okay, मैं एकदम ठीक हूँ यार, एकदम बढ़िया. ठीक है. Okay. Okay guys. Okay. Ansh Gorian, stop spamming. Ansh, Maggie was also यार. 2 मिनट में वही खाई जा सकती है ना. Okay. अरे मनन चौधरी मेरे बच्चे, look at the session number before asking the question. I have no idea, Aditya, how is Harsh doing. I have not been able to speak to him. Okay. Sir, did students ever approach you in Mumbai? Fortunately, no. Sorry, यार, मी चांगला है. Okay, Captain Arshad. What happened, Nihal? Hello. अरे यार ये क्या है? ये pedagogy का क्या है? क्या सीन है pedagogy? हाँ? बस ये प्रशांत मुझसे पूछ रहा था what is pedagogy? अरे मुझे तुमसे पूछना चाहिए what is this going on in the chat box? Pedagogy OP चल रहा है मेरे हिसाब से तो chat box पे. Sir, I'm new to the batch. Welcome to the batch. Welcome to the family then. सर सेशन टाइमिंग चेंज होगा. अरे यार ये तुम ही लोग बोल रहे हो कि सर कोई मीटिंग है, शिमोन सर ने बोला है, तो तुम शिमोन सर से पूछो ना. मैंने तो आज तक नहीं बोला कि टाइमिंग चेंज हुआ है, पर घूम करके तुम लोग हर बार क्लास में आ जाते हो डिस्कशन करने. एपी सर अनाउंस्ड इट. चलो बढ़िया. तो नए टाइमिंग क्या होने वाले हैं वो भी बता दो यार, मुझे तो किसी ने बताया नहीं. नए टाइमिंग क्या होंगे भी बता दो. आनंद सर का गिफ्ट है पेडागॉजी. चलो अच्छी बात है यार. रात 12 बजे से सेशन होंगे. अच्छा, और कुछ? पेडागॉजी फ्री बुक्स. चलो बढ़िया है. सर आपको केमिस्ट्री का फेस टेस्ट का डेट पता है क्या? और कुछ पूछना है तो वो भी पूछ लो, है ना. सर आज से 5 दिन बाद क्या इवेंट्स होने वाले होंगे बता दो. वेदांतु हैज शेकन हैंड्स विद पेडागॉजी. दैट्स गुड, वेरी नाइस. सर पैरालंपिक्स में कितने मेडल आएंगे? अच्छा, और बोलो. Chemistry 5th September and Maths 19th September. People who wanted to know, I think this is the date for face test. Again, subject to verification. अरे यार संकेत ध्यान, क्यों ऑन? सर बाय अ ऑडी Q3. क्यों Q5 क्यों नहीं, Q8 क्यों नहीं? Q3 में ऐसा क्या है? सर आर यू फीलिंग स्लीपी? ऑब्वियसली ऐसी बोरिंग बातें कर रहे हो तुम लोग चैट बॉक्स पे. फीलिंग सुपर स्लीपी ऑलरेडी. Anyway, everybody, interesting people in the class. Shubham sir, Sunil sir, Gautam sir, and Rishabh sir. Say hi to your class teachers, and then we'll start the class. That's great. चलो भाई, बहुत अच्छी बात है. अरे यार तुम्हारे घर में कौन सी कार है वो जाके इंस्टाग्राम पे बताओ लोगों को, क्लास में क्यों बता रहे हो? जाके इंस्टाग्राम पे फेमस हो जाओ. यहाँ पे कोई फॉलोअर नहीं मिलेगा. ओके. हाँ जी. ठीक है. चलो guys, let's start the session. Everybody ready? Write class one in the chat box if you are ready. It's a new chapter. We completed circular motion last time, and now we are starting a new chapter from today. So it's now we can say that we have actually completed level 1 of physics of 11th standard. Means you have now a base. After completing circular motion, a base is ready. Means what? Henceforth, you can expect questions where multiple concepts will be involved. Okay. Start करें. चलो. Okay guys. So switching off the chat, you know what you don't have to do. Please do not write anything in the doubt panel which is not a doubt. Okay. Good. Sir, what is center of mass all about? चैप्टर पढ़ लें तब तो समझ में आएगा what is center of mass all about. पहले तुम्हें पूरी समरी चाहिए, चैप्टर पढ़ा भी नहीं है. हाँ, मतलब मूवी देखी नहीं कि सर मूवी व्हाट इज इट ऑल अबाउट. ठीक है. चलो गाइस, स्विचिंग ऑफ द चैट एंड प्लीज डू नॉट राइट the random things that you people are typing in the chat box. Please do not write those in the doubt panel. If any class teacher tells me that this guy is creating a nuisance in the chat box in the doubt panel, I'll be really forced to actually block you. I don't want to, I don't like to, but today I got this feeling that some of you are in a mood of creating nuisance. This is my vibe today. Okay, so I don't want to block anybody, so please don't make my life difficult today. I don't want to block anybody from the class, so please behave in the doubt panel. Class teachers, am I clear to you? Class teachers, if you find people creating nuisance, you just let me know. Okay. Okay. Nayan, I do not give time to make notes in the class. I do not. I'm telling you this very upfrontly. If I will do this, if I will give 60 seconds for every slide, even if there are only 20 slides, I will require to give you 120 minutes. And 120 minutes is the duration of this class. Okay. So do not expect that because that is practically not possible. Instead, all the important formulas that you see in the class, you just note them down. Try to understand the class. Try to take notes from here. That's I always say that. And in which way you will have the PDF of my session after the class. Okay, guys, let's start the session. So what we are going to speak about in the session is about something which we call as center of mass. And I always start the session of center of mass by trying to demonstrate the balancing of the pen on the finger. This pen which you see is getting balanced on my finger. That's the only place of the pen where it can get balanced on the finger. Right, everyone? Even if I will try to do this anywhere else, if I will try to balance it anywhere else, will be unsuccessful. You know that there is this particular point where the pen gets balanced. You know that, right, everyone? You can try this with the pen that you are holding right now. So guys, the point is, this chapter is about balancing point or finding the balancing point. That balancing point of maybe a solid body or maybe multiple bodies which are not physically connected to each other. Means what? there is a possibility when we speak about system of particles, system of masses. That means what? Just try to imagine solar system, and that too being seen from a very, very, very far away. So solar system, all the planets, including Earth and the sun. Sun is not a planet, you know that. All of them look like a teeny tiny particles. So trying to find out that point where solar system can be theoretically balanced, okay, or a solid body like a pen, a solid body like a bottle, a solid body like a rectangle, a solid body like a sphere, okay, multiple things which are solid bodies. We will try to find that balancing point for them as well. This balancing point, my dear friends, is what we call as the center of mass. That means, in very simple words, we will be first speaking about what center of mass will be spoken for, means what are those objects. So to understand that, we will actually categorize our bodies into two types. The first will be called as a point object. The point object which you see on the screen is actually bigger than the point object that we actually want to define. Point object is something which you can't even say has any radius. Even if you consider it to be a sphere, a point object is that thin, that small, that weak, that you can't even define a radius for it, you can't even define a size for it, it is that small. So that's why it says that it has no physical extent. That means what, you can't even speak about its dimensions, it is that thin. Or I should say that every solid object, if I break it down, keep on breaking a solid object down, the smallest of the particle which is making a solid body is what we are saying as a point object. Okay, guys? Then it is clear that the solid object, which is made up of multiple point objects, has to be given a new name. It's called extended object. So it has a physical extent, it has physical boundaries. You can see physically this pen has physical boundaries, that bottle that I was holding has physical boundaries, shape, size. All the particles of this body are not at the same location. So basically, we will try to first speak about point objects, multiple point objects, and then we'll speak about collection of point objects giving a shape to an object. Okay, guys? So let's move on and speak about the center of mass. So what exactly is the center of mass? I want you people to first see the animation here. Not exactly animation, this is GIF file. I hope this works. Yeah. So see this bottle will be balanced, even when it looks like it is not possible to balance it in this way. So you see that without any rope or anybody holding the bottle, in a very dramatic fashion, the bottle was actually balanced over there. Okay, so definitely it is possible. That is why this video is there. Apart from that, you might have seen the rotation of a basketball or a football being done on one of the fingers. The ball is not falling. Okay, so basically this balancing act has something to do with the discussion that we are going to have today, which we call as the center of mass. Let's first formally define what center of mass is. Center of mass, as you saw the first demonstration that I gave you, is basically the point which is lying for a body, for a system of particles. That will be much more appropriate. Okay, even a solid object is made up of small particles. So everything in this universe can be said to be a system of particles. Okay, so system of particles, they will have an imaginary point. Remember, listen to me very carefully. Don't need to even write it down. That definition will come in which way in the next slide. For a system of particles, be it discrete system of particles, discrete means what? Where particles are actually placed at different places, you can see them differently, individually, or a collection of particles which gives an object a shape. This is also a collection of particles made up of multiple particles, right? So for any kind of system of particles, that imaginary point where I can say entire mass of the system, if I compress it and place it at that point, will behave exactly the same way as the entire system of particles is behaving. Means what? Just look at that person rotating the football. If I compress that as in basketball, even if you compress the entire basketball and convert it into a point mass, and that point mass is kept on the finger of that person, it will still have the same dynamics, it will still have the same forces acting on it, behaving in the same way, having the same energy, is what we try to define as center of mass. So basically, center of mass is a hypothetical concept. Why do we define it? We define it so that some complicated motions, unlike the straight line motion, there are many complicated motions that we are going to study. They become much more easier for us to study and understand the mechanics of the object. Become much more easier when we speak about the center of mass. So formally, when we speak about the center of mass, you can see that the definition written on the first few lines. Okay, so for system of particles, center of mass is that point which is total mass, which its total mass is supposed to be concentrated at, right, everyone? And the center of mass of an object is a point that represents the entire body and moves in the same way, and as a point mass having mass equal to that of the object. That means, as I said, I will basically compress the entire mass of the body. So amount of mass remains the same, right, everyone? The mass value remains the same as that of the entire object in that system, and when subjected to the same external force, it behaves exactly the same way as your system was behaving. Okay, very interesting concept, guys. It is. Okay, so directly jumping to how exactly we find out the location of the center of mass, and to make it much more easier for us to understand, I have divided this entire discussion into 1 dimension, 2 dimension, 3 dimension arrangement of the system of particles. We will basically try to define center of mass for 2 categories. Okay, so let me first define those 2 categories for you. Okay, so there are 2 types of particle systems that we study. We study discrete mass system, and we study something called as continuous mass system. Okay, so one is discrete mass system. Okay, the other one is called continuous mass system. Okay, this is when you can identify individual particle and the boundary. And here, when you can't identify boundary between particles, means where exactly one of the particle is starting, where it is ending, where the other particle is starting, is continuous mass system or continuous particle system, like this bottle. There is so many particles that this bottle is made of, but you cannot pinpointedly tell where one particle is and where is the other particle starting from. The boundary between them is so seamless, you can't actually talk about that. Okay, guys. So first, obviously, the discussion will be started with discrete mass system, and for discrete mass system, also I divided that discussion into 3 categories. 1D mass system, where masses are arranged in a line. Then we'll speak about a 2-dimension arrangement where particles will be arranged in a plane, multiple particles, and then we'll take them into space, 3-dimensional arrangement. That means what? When your particle arrangement is such that they are only having single coordinate, the other 2 coordinates are 0. Then for 2D, only 2 coordinates will be there, third coordinate will be 0, and 3D, just like 3D vector, will have all the 3 components. So everyone, the first is the discussion of center of mass that we want to find out for 1D system. 1D system is the one where we are arranging the particles on a straight line. Okay, do I have to only talk about 2 particles? No, there could be multiple particles. I'll speak about that also, starting the discussion with the arrangement of 2 particles. In fact, if there would be only 1 particle, then guys, wherever the particle is, the center of mass of that body also lies on that. Okay, I forgot to mention this point, everybody. You might also be thinking while going through slides so far, you might also be parallelly thinking about, is center of mass and center of gravity the same thing? So let me tell you, center of mass exists even when gravity is not there. But the same center of mass, when you start taking that system of particles in the gravitational field, that center of mass will be started to call as center of gravity. That means what? This mass, this body, even if it is placed in a gravitational free space, even if you take it in a space where there is no gravity, its center of mass will stay where it is right now. Okay, with the point where it was getting balanced. When I was trying to balance it, by the way, I was actually trying to balance it in gravitational field, because if I will not be able to balance it, it will fall down. Fall down means what? Fall into gravity. So right now that point where center of mass is also center of gravity, because I'm dealing with it in the gravitational field. Because I am right now trying to balance the gravitational force of this center of mass. Right? The entire mass is concentrated at this point, trying to act downward as a single point particle. That means what? If I remove this pen and I just place a point mass on my finger, that point mass, its gravitational force will be trying to pull it downward. I'm actually balancing it by applying a force upward. Okay, guys. So henceforth, please do not have the doubt that center of mass and center of gravity are two different concepts. They technically are different concepts, but for us, center of mass and center of gravity will practically behave in the same manner. Okay, so center of mass is more fundamental concept. So everybody, for a point mass, you don't actually need to define the location of center of mass for a single particle, because in single particle, wherever the particle exists, its center of mass is also with it. But when the discussion is about two particles, so everyone, when M1 and M2 say they are connected by an imaginary rod, a massless rod, say M1 and M2 are connected by a massless rod, and that massless rod I'm trying to balance. So the point where these two particles will be balanced, like a seesaw, is the point where center of mass exists, and I'm trying to locate that. How do we locate that? Is the formula which is written on the left side of it. I know many of you might right now be thinking about how this expression comes, how this formula comes, M1 x1 plus M2 x2 upon M1 plus M2. First of all, right, I will tell you guys what exactly is x1, what exactly is x2. M1 and M2 are basically the 2 point masses. X1 is the location of particle M1. Okay, means if I want to talk about the coordinates of M1, I will say it is x1, 0, 0, and for M2 the coordinates are x2, 0, 0. Means I'm saying that particles are actually placed on x-axis. That's why they only have x coordinate. Okay, guys, so I hope there's no confusion there. Okay, so everybody, we are clear with what is M1, what is x1, what is M2, what is x2. What you see as xcm is, my dear friends, the x coordinate of the center of mass of both the particles, where basically the total M1 plus M2 mass, if you create a particle of mass M1 plus M2, and where should I place it so that it behaves exactly in the same way as M1 plus M2 behaves? As the two particles behave, that point where I need to place the center of mass, or where actually it is placed, is the location of center of mass xcm. Okay, guys. By any chance, I am very doubtful of that. If we are left with some time at the end of the session, I will tell you how exactly this expression comes. Right now, it is actually not under our domain of knowledge to be able to derive it directly. Its derivation actually will be possible when we have studied a chapter called as rotation. Okay, but still I will make an attempt. If we are left with decent amount of time, say around 10 minutes time, at the end of the session, I'll give you the derivation of this part as well. But right now, I want you people to just trust me and note this expression down. This is the x coordinate of center of mass, or the location of the center of mass of two particle system. This is a two particle system that you see. Okay, this is a two particle system, the center of mass, because you see there are only two particles. Okay, so everybody, if there are more particles placed on x-axis, if I will have like M1, M2, M3, M4, M5, M6, but placed on x-axis only, that means one dimension. One dimension is one of the axes. So in that case, you will be able to write the similar expression, x coordinate of center of mass. You will be able to write it as M1 x1 plus M2 x2 plus M3 x3. As many particles are there, you need their mass, you need their location, and divided by the total mass, M1 plus M2 plus M3, up till as many masses which are there. Okay, guys. So, sir, when we speak about 1D, location of center of mass, is it only supposed to be on x-axis? No. If the particles are arranged on y-axis, then you will be writing y coordinate of center of mass, because your center of mass will also lie there on that line only. So the y coordinate of center of mass will have the similar formula: M1 y1 plus M2 y2 plus M3 y3 divided by M1 plus M2 plus M3, as many masses which are there, and same goes for z component of center of mass. Okay, guys. Now, more importantly, for a two-particle system, say as of now, what you saw in the derivation, that my particles were not placed on origin. None of them was placed on origin. Even the center of mass definitely will come somewhere in between the line joining the two masses. Now what I will do, I will try to arrange my coordinate system in such a way that center of mass location is treated as the origin. Okay, you see that in this diagram, the center of mass coordinates are origin. I hope everybody is able to have a clear look at it. I have defined the location of the center of mass to be 0, 0. Okay, which means what? M2 is placed, M2 is placed on the positive side of x-axis, and M1 is placed on the negative side of x-axis. And I want to make one change here. I want to write their respective locations as x1 and x2. Okay, guys. The only thing is, this side is positive x, this side is negative x. So now, when you try to write down the x coordinate of center of mass, it itself is 0. Okay. Why? Because now my center of mass is placed at origin, or I should say, whatever was the location of center of mass, I've assumed it to be origin. So that simply means what? M1 x1 plus M2 x2 by M1 plus M2 that I write. Okay. In this, the correction or the change, not correction, but the change would be x2 is on the positive side. The measurement of x2 will be positive, while the measurement of x1 will be negative. That means M1, its location is minus x1, because to reach M1, I have to move on the left-hand side, which is basically the negative side on x-axis. Okay, guys, that M2 lies on the positive side of x-axis divided by the total mass. So you see that this M1 plus M2 goes and multiplied here. I have minus M1 x1 equal to minus M1 x1 plus M2 x2 equal to 0, and more importantly, M1 x1 is equal to M2 x2. Just one small thing that I want to tell you people is, what do we mean, or what should we understand as the product of mass with the location of the mass? Means what is M into x? Okay, M into x is understood as mass moment. As of now, you have to just accept what it is called. I will give you the understanding of it. My promise. Maybe if not in this chapter, the very next chapter, which we call as rotation, I will give you the understanding of this as well. Okay, and if time permits today, I will give you the entire idea. Right now, what is the expression which is in front of you? If you consider the center of mass to be at origin, or if you try to find out the mass moment about center of mass, means what? What you are doing here? You are considering center of mass to be the point where balancing is happening, and you have also considered that point to be your reference point. Generally, origin is considered as the reference point. So if my center of mass is the reference point, then about center of mass, the mass moment of M1 and the mass moment of M2, their magnitudes will always be equal. Means what? The balancing point is such that if the two masses, if the two masses are equal, then their locations will be such that they are also equidistant from center of mass. Seesaw situation. But you know that in a seesaw, you cannot actually change the point where the balancing has to happen. So if two unequal mass people stand, then the seesaw is not balanced. That is why the heavier person has to come closer to the center of the seesaw, right, everyone? So the heavier person comes closer because his mass is more. X has to be reduced so that m1 x1 becomes equal to m2 x2, so that the center of mass comes exactly where the hinging has happened for a seesaw, right, everyone? Thoda feel aa gaya hai? Are you guys able to get the feel of what is happening so far? Okay, I'm not saying it is 100%. The derivation and all is not done, but please remember. Okay, cool, everyone. Chiranjeeva, hello, Chiranjeeva. Chiranjeeva, this is not the right platform for you to ask for changing your batch. This is the class going on. You do understand it's a back-end operation. You need to speak to your SAM. Please do not make class teachers life difficult. Okay. Okay, guys. So this is a very important result, and more than the result, the understanding of it. Okay. So this was how you were finding the location of center of mass. One of the axes when the masses are lying, the location of the center of mass. Now, if I place m1 and m2 anywhere in this plane, that means what? The coordinates will not only be x coordinate, will not only be y coordinate. X and y both are present. X and y coordinates both are present. So what? Instead of finding only x coordinate, I will also find the y coordinate. See, now m1 has x1 and y1 coordinate, m2 has x2 and y2 coordinate. So what will I do? I will first look at the x coordinates, find out the x coordinate of center of mass. Same formula, m1 x1 plus m2 x2 upon m1 plus m2. Same I will do for y coordinate, m1 y1 plus m2 y2 upon m1 plus m2. And if I get x1 and x and y coordinate, okay, how will I solve it? How will I rather represent the center of mass? I will simply say that the position of the center of mass is x coordinate I cap plus y coordinate j cap. Means whatever I have found here, I will actually be placing it here. Okay. If you have already been given the r1 and r2 vector, what is r1 and r2 vector by the way? These are the position vectors. You see that r1, you see r2. Everybody remembers the position vector? Yes, Manan Chaudhary. Good evening. अगर ये seesaw है, if this is seesaw, you know that seesaw का जो balancing point दिया हुआ होता है वो हमेशा center पे होता है. Can I say that only when two equal mass people will stand on the extreme ends, then only they'll be able to balance the seesaw? So if this guy has 40 kg mass and this guy has 80 kg mass, will the seesaw be balanced? So who should move closer? Who should move closer to the center? Exactly, that's what I was trying to tell. He will have to come closer because his mass is more. So that his mass multiplied by this x is equal to the mass of 40 kg person and the location of that person. That is what I meant. Okay. Okay, guys. So I hope this is clear that if you have been given the position vectors, I will give you examples later on after explanation of this part that you will understand this better. We will solve the questions also. Okay. So if r1 and r2 vectors are given, you can directly put r1 and r2 vectors here and get the final position vector also, or you can individually find out x coordinate of center of mass, y coordinate of center of mass, and then go ahead to find out or represent the position vector of center of mass. Okay, guys. So I guess now you can already predict what is going to happen in 3D. There will be three coordinates. So m1, x coordinate, y coordinate, and z coordinates of center of mass as many particles which are there. I'm not even putting a restriction that there are only two particles. The most generic case, you can have n number of particles. When I say n number of particles, they could be 5, they could be 10, they could be as many as the number of stars in the universe. So m1 x1 plus m2 x2 plus m3 x3 plus m4 x4, as many masses are there, divided by the total mass m1 plus m2 plus m3 plus m4 up till the final mass. Same will be applied for y and z coordinate, and you will be able to write down the final location of the center of mass as x coordinate of center of mass I cap plus y coordinate of center of mass j cap. This is what we learned in the chapter of vectors, right, everyone? Cool. Let me give you guys an example for you to have a better understanding of the application of the formulas here. So I'm starting off directly with a 3-particle system, not even starting with a 2-particle system, because if I make you people understand 3 particles, then 2 particles will be a piece of cake. So see this, you have 3 particles which are placed in such a way. Let's give them name also. This is A, this guy is B, and this guy is C. Okay, so you can see that the coordinates of particle A, whose mass is 2m, is 2, 0. Particle B also has mass 2m, but coordinates are 0, 2. Placed on xy plane, obviously you can see that xy plane it is. And the third particle has only mass m, half of the other two masses, and coordinates are 4, 4. Okay, so let's try to find out their coordinates of center of mass. Starting off, everyone. If I want to find out the x coordinate of center of mass, I will say it is m1 x1. Religiously solving it so that you all get to remember the formula also. m1 x1 plus m2 x2 plus m3 x3. Whole thing divided by m1 plus m2 plus m3. So there are 3 masses. I will write only 3 times divided by the total mass, which is m1 plus m2 plus m3. Right, guys. So let's define A as our first mass, B as our second mass, and C as our third mass. So the first mass is 2m. Its x coordinate is 2. Whatever be the units, we have not been given the units. Would be meters, would be centimeters, would be kilometers. We don't know that. Okay. M2 is also 2m. This mass is 2m. Its x coordinate is 0. Okay. And m3 is m. Its x coordinate is 4. And whole thing is divided by m. Whole thing is divided by 2m plus 2m plus m. So what do I get? 2m into 2 is 4m plus 0 plus 4m divided by 5m. Okay. So what do I get? I get 8m by 5m. Obviously, m and m get cancelled. And what do I have here? Finally, is the x coordinate of center of mass. 8 by 5. Cm means center of mass x coordinate. Okay, guys. If the units would have been in meters or centimeters, I would be writing the location of the center of mass x coordinate. Okay. Similarly, let's try to find out the y coordinate. Okay, everyone. So we are already done with x coordinate. Let's go with the y coordinate here. Don't worry, I have duplicated the slide. You will have the notes where you will have the y coordinate and x coordinate both being present. Okay. More importantly, guys, I am going to deal with only x and y coordinates in this example. Why? Because the 3 particles which you see in the question, 2m, 2m, and m, they are lying in xy plane. So there is z coordinate of the center of mass already equal to 0. So let's try to find out the y coordinate of center of mass. This time I'm going to directly let me write down the formula and then we'll remove a bit of steps. Okay. Just writing the formula first. Yeah. So the first mass is 2m. Its y coordinate is 0. Y coordinate is 0. Second mass is also 2m. Its y coordinate is 2. Third mass is m. Y coordinate is 4. Divided by 2m plus m, that is 5m. Okay. So this is 0 plus 4m divided by 5m. That means the y coordinate will also come out to be 8 by 5. Okay, and the z coordinate of center of mass is going to be 0. So finally, I can represent, though I've got the answer already, I can represent the final answer as 8 by 5 I cap, 8 by 5 j cap plus 0 k cap. I don't actually have to write down 0 k cap, but for the first time we are solving a question in this chapter, that's why. Okay, so 8 by 5 I cap plus 8 by 5 j cap somewhere here is the center of mass. Okay, 8 by 5, that means it is less than 2. Somewhere here will be the center of mass. How much mass is placed here? 5m. Okay, everyone, I hope this made sense. Made sense to all of you? This was the x coordinate, this was the y coordinate. Okay, guys, as you can see that finally all the masses are getting cancelled, so you don't actually need to convert the masses or the distance also into SI units. Okay, no, we don't need to. Okay, why center of mass is 5m? Because the total mass of the system is 5m. So center of mass is the point where entire mass of the system will be placed. Okay, why 0 k cap? Because the three masses are placed in xy plane only. There is no z coordinate. Even if you will apply the same formula, m1 z1 plus m2 z2 plus m3 z3 by m1 plus m2 plus m3, z1 z2 and z3 would be 0. Hence the center of mass would also have 0 z coordinate. Okay, no problem, Chiranjeevi. Okay, आगे चले, थोड़ा एक level आगे का question देखते हैं, then you guys will solve the questions. Okay, so this time have a look at this. We have three particles once again. They have masses also given as 1 kg, 3 kg, and 2 kg. So I'm going to give them the name as per the alphabets. This is m1, this is m2, and this is m3. So you can see that m1 already has coordinates which are 0, 0. Let me just make a copy of the slide so that you guys, okay, you guys get to see the question also. So everyone, m1 is coordinates with 0, 0, and very easy I can write down the coordinates of m3 also. M3 coordinates are this is 1 meter, right? So x coordinate is 1 and y coordinate is 0, and this is a two-dimensional question once again. There is no third dimension. Z coordinate is 0. I need to find out the coordinates of m2. So anybody? Coordinates of 2 kg particle at B. X coordinate first of all. Okay, so we need to find out this distance without even solving. The x coordinate is half. B is placed symmetrically. So can I say that AC is bisected by this dotted line? Right, everyone? Without any mathematical knowledge, can I directly say that m2 का x coordinate is going to be half a meter? Yes, right? जो भी बोलना है उसे, इक्विलेटरल ट्रायंगल में परपेंडिकुलर बाइसेक्टर मीडियन होती है, इतना मेरे जैसे इलिटरेट इंसान को भी पता है. ओके, दूसरी चीज, आई नीड टू फाइंड आउट द y coordinate. I need to find out the y coordinate. This is 1 meter, this is 60 degree. Can I say that from our knowledge of vectors, this is going to be 1 sin 60 degree? ऐसा ही लिखते थे. This is 1 cos 60 degree. दूसरा तरीका है ये बेसिकली पता लगाने का. If you guys are not very comfortable with mathematics and trigonometry, you can go by this also. Hypotenuse is known to you. You can find out the other two sides very easily. Okay, so sin 60 is what? Root 3 by 2. Right? Everybody is happy? It's not root 5 by 2. It is root 3 by 2, Shweta. Okay. So we have the coordinates of m2 as 1 by 2 and root 3 by 2. Do the maths. I've already given you the clues here. Now I will just directly take you guys to finding the x and y coordinates of center of mass. This time I will directly just put up the masses m1 x1 plus m2 x2 plus m3 x3 divided by the total mass. Okay. So first mass is 1 kg. Its coordinate x coordinate is 0. Similarly, the second mass is 2 kg. This mass. Its x coordinate is half. Okay. Third mass is 3 kg. Right, everyone? Third mass is 3 kg. Its x coordinate is, its x coordinate is 1 divided by the mass. First mass is 1 kg. Second mass is 2 kg. Third mass is 3 kg. Okay, guys. X coordinate 0. X coordinate 1, 0, so x coordinate is 1 and x coordinate is half. So everybody, this is 0. I have 1 plus 3 divided by 6. So I have 4 by 6 or 2 by 3 meters as the x coordinate of center of mass. Okay. Similarly, I will put this for y and just have a look at this. 2 by 3. Similarly, for y coordinate, when we put it 0, 0, 1, 0, and this one had half comma root 3 by 2. So you can see that mass m1 and m3 are already on x-axis. Their x coordinate is anyway 0. So 0 and 0 are being placed. Only the 2 kg mass as y coordinate, that is root 3 by 2 divided by the total mass. This 2 and 2 get cancelled. Root 3 by 6 is what we get. When we find out the distance of the center of mass, I have got the x coordinate, I have got the y coordinate, so I can find out the distance of the center of mass under root 3, basically finding the magnitude of the distance of the center of mass location. We are just finding the magnitude of position vector. यहाँ पे मैंने position vector पता लगाया था. Harshan was asking, sir, do I need to find out the magnitude of it also? Here we did not need to find the magnitude of this r vector, but in the present question they're asking us to find the distance of the center of mass from A, which is basically finding the magnitude of r. So under root of 2 by 3 ka square plus root 3 by 6 ka square, answer is in front of you. Mathematics is not what I'm teaching you. This is how the center of mass. Okay. चले एवरीवन, इस भाई को बता दो यार क्या है ये, जनरल नॉलेज कम हो गई इसकी बहुत. थोड़ा टाइम बताओ इंस्टाग्राम पे, सब समझ में आ जाएगा अपने आप. मतलब एक तो इंस्टाग्राम पे टाइम नहीं बताते, फिर आके यहाँ पे अपनी जनरल नॉलेज बढ़ाने. ठीक है, चलें भाई, सवाल करें। बहुत 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 चैलेंजिंग सेशन है आज का मेरे लिए, क्योंकि बहुत सारी चीजें आज एक ही सेशन में पावर पैक तरीके से पढ़ानी है, और चैप्टर एक्चुअली उतना इजी है नहीं। अभी तक तुम्हें बहुत इजी लग रहा है, बट ये सेशन बहुत जल्दी बदल जाएगा। चैलेंजिंग है चैप्टर, ठीक है। चलिए जरा क्वेश्चंस करें एवरीवन, starting with an easy question. Two particles of mass 1 kg and 2 kg are located at x equal to 0, x equal to 3. Find the position of the center of mass directly, giving you only 45 seconds. Time starts in 3, 2, and 1. I hope you have written the formula already. It is only a application of formula, nothing else. Quick. चलो, last 5 seconds. आज क्लास एक्सटेंड हो सकती है, मैं फिर बता रहा हूँ, सॉरी पहली बार बता रहा हूँ, बट हाँ आज क्लास एक्सटेंड हो सकती है। क्या बात है, चलो फॉर्मूला अप्लाई करना तो सीख गए, ठीक है एवरीवन। सो करेक्ट आंसर इज दिस, व्हाई? बिकॉज़ एक्स कोऑर्डिनेट ऑफ सेंटर ऑफ मास इज m1 x1 प्लस m2 x2 अपॉन m1 प्लस m2। तो पहला मास 1, एक्स कोऑर्डिनेट 0, दूसरा मास 3, सॉरी दूसरा मास 2, द एक्स कोऑर्डिनेट इज 3 एंड मास इज 1 प्लस 2। okay, so this is 6 by 3, that is 2 meters. The units are given in meters, that's why. Easy. Cool. Awesome. Next one for all of you. Look at this question. This is from JEE 2020. Very easy actually. Question has 3 masses given to you, and I have already kind of given you the coordinates, told you which one is m1, which one is m2, which one is m3. So you have to locate the center of mass and choose the right option. Okay. So you have to choose m1's location as the origin. m1 is located at origin. That's what you have to look at. This mass is placed at the origin. 1.5 is 3,0 location, and 2.5 kg 0,3 location. You have to find out the location of their center of mass. I'm giving you all 90 seconds for this, and your time starts in 3, 2, and 1. Oof. Last 15 seconds now. Okay, and the time is up. Let's see. Good. So yeah, you already have the mass values: 1 kg, 1.5 kg, 2.5 kg. Coordinates are given. Let's directly see the solution. m1 x1 plus m2 x2 plus m3 x3 divided by the total mass. First mass, x coordinate is 0. Second mass, x coordinate is 3. Third mass, x coordinate is 0. So 1.5 into 0, 2.5 into 0, and 1.5 into 3. So this part becomes 0. This part also becomes 0. This is 4.5 divided by total mass, that is 5. This is 0.9 centimeter. Okay, so x coordinate found. Similarly, let's find out the y coordinate. So y coordinate is 0, 0, and 4. So 1 into 0, 1.5 into 0, and 2.5 into 4. So ये तो 0 हो गया. You have 10 by 5, 2 centimeter. Very easily you got this. Answer came out to be 0.9 centimeter to the right and 2 centimeter above. So 1 kg mass. 1 kg mass से right में है और ऊपर ही है, यहाँ नहीं है. That's what it is. Cool. Power packed. One more question. This time our coordinates, instead of giving the individual coordinates, they have given you the position vector. So you directly have to put the position vectors here, multiply with their individual masses. 1 kg location R1, 2 kg location R2, 3 kg location R3. All position vectors R1, R2, R3 divided by the total mass. Find out the location of the center of mass in terms of position vector. Giving you 90 seconds once again, and your time starts in 3, 2, and 1. Come on, people. Last 25 seconds, all of you. Okay, let's see. So देखो क्या करना था. Formula taken there. The location position vector of center of mass will be the first mass, that is 1, multiplied by its own position vector 4 I cap plus 2 j cap minus 3 k cap. Okay. After that, second mass, that is 2 kg, then its position vector, that is I cap minus 4 j cap plus 2 k cap. Then you have third mass, that is 3 kg, and the position vector is 2 I cap minus 2 j cap plus k cap divided by the total mass 1 plus 2 plus 3, that is 6. So this is 4. All the I cap components I will write together now. From here, 1 into 4, it's 4 I cap. Okay. So 4 I cap plus 2 into 1, 2 I cap. So that is 4 plus 2. Confuse हो गए? चलो कोई बात नहीं. 4 I cap plus 2 I cap plus 3 into 2, 6 I cap. ये समझ में आ रहा है? Everyone, I have written all the I caps together. Let's write J caps together. So 2 J cap, 2 into minus 4 is minus 8 J cap, and 3 into K plus 3 K cap, and last component is 1 into minus 3. So minus 3 K cap plus 4 K cap, and last is plus 3. Oh, made a mistake here. 3 into minus 2. 3 into minus 2 minus 6 j cap आएगा, हाँ minus 6 j cap, and the last will be 3 k cap. अभी ठीक है, and whole thing divided by 6. So everyone, 4 plus 6 10 10 12 12 by 6 is 2 I cap. Okay, this is how much? 14 minus 2 12, तो minus होगा, minus 12 by 6, this is 2 j cap, and last is how much? 3 और 3 cancel हो गया, तो 2 by 3 बचता है finally, plus 2 by 3 k cap. Okay, got it? Plus 1 if you got this. Very good. So now you guys are equipped with the calculations of center of mass. Okay. नहीं विहान तुम कुछ और डायरेक्शन में जा रहे हो, ठीक है? ओके, हाँ वो नहीं करना है जो तुम सोच रहे हो, ठीक है गाइस. ओके सर, k cap once repeat written over here, there is nothing to repeat, just multiply 1 with this, 2 with this, and 3 with this. So see this, 1 multiplied by minus 3 k cap is minus 3 k cap, 2 multiplied by 2 k cap is 4 k cap, 3 multiplied by k cap is 3 k cap. Okay, it's actually more of self practice. Okay, चलो अब आते हैं उस चीज पे जिसके बाद मैं फीडबैक लूंगा कि कितना इजी लग रहा है तुम्हें चैप्टर, ठीक है? नाउ विल स्पीक अबाउट सेंटर ऑफ मास ऑफ डिफरेंट शेप्स. ओके ओके, चलें एवरीवन. शुभातमन दास, डू यू हैव अ माइक्रोफोन? कैन यू प्लीज एक्टिवेट योर माइक्रोफोन? Shubhataman, I'm speaking to you. Are you there? अरे आगे easy है यार. It's not working. Shubhataman. Aryan, mind your language. Auto blocking होता है वेदांतु में. Remember that. I hope some people have given a feedback at times that I got auto blocked by the system. The system has filters like YouTube. If you will use any foul language, it will naturally block you, automatically block you. So please do not try to write any foul language in the chat box. If you want to test the system, please. Okay. Mic done. Shubhataman Das, mic is not done, bacha. This is the feedback by the system right now. So anyway, Shubhataman, please keep this doubt. I will answer your doubt at the end of the class. Can't stop the class entirely. Okay. Chalo guys, switching off the chat, and for next 15 to 20 minutes, at least 15 to 20 minutes, there will be no problem solving. There will be only theory, and probably the first time that you will see integration being used extensively. When I said this chapter is a landmark chapter, you have actually completed a good amount of physics. From here, things are going to take a new shape. The calculations, or rather the application of calculus, will be increased. So I'm not saying it is going to become difficult. It's not going to be difficult. Only when you try to listen to me. Only when you try to understand what I'm trying to say, instead of creating doubt just because you want to ask it out. Okay. Try to keep your mind clean. Try to keep your understanding simple, and try to only interpret what I'm saying. Do not over-interpret what I'm saying. Okay. Because there is no end to doubts if you try to just bring the doubts. Try to just synchronize with me. Try to converge with me instead of diverging. You will actually understand. And let me tell you what is going to happen. You, whoever teaches you at this moment of time, not just me, whoever teaches you at this point of time, this part which is about to come, you will not have 100% understanding in the very first round of the discussion. That means what? Today, whatever I'm going to do from here till at least next 10-20 slides, I want you people to watch the replay of it at least 2-3 times. Then maybe you will be able to get the feel of the integration application here. Okay? So now all eyes on the screen. Keep your doubts noted. I will answer them obviously towards the end of the class. Why did I say that nobody understands this 100% in the first book? Because it's the application of integration, what we are going to see very soon. And integration is not done in mathematics yet. It will be done in 12th standard. So definitely the overall idea of integration is not very clear to all of you guys. So this is the very first time that we are seeing the application of it. And that is why the chapter is found challenging by many students. I will try my best to make it easy, to make it super duper easy for all of you. Just listen to me very carefully. Okay. So everyone, now we are going to speak about the center of mass of continuous mass system. That means what so far we were speaking about the individual masses, they were placed somewhere. We had the coordinates of all the masses. Now you're speaking about the continuous mass system, where you cannot say where one of the masses is, where the second mass is, where the third mass is. You cannot locate the different particles. So now what I'm saying, instead of contradicting, try to listen to this so that you remember this part, the understanding of it. Whenever we deal with a continuous mass system, we basically try to visualize it. We try to look at it as an object which is made up of multiple point masses, almost tending to infinity number of point masses. A body is made up of infinite number of point masses is what we'll assume. All the masses, when added together, will give you the mass of the entire body. So say the entire body has a mass capital M. I will assume that it is made up of small point masses, and all point masses are of equal mass. All the point masses have equal mass. Okay, and that mass is dm. Dm, you will understand from integration. Dm is that small value of mass. D represents any measurable value. That means dm is that small mass which you can't actually measure. So this small dm mass, if it is given, or it is the unit value of the mass, if I will add all the dm masses, I will be able to get the entire mass of the body. So we will try to locate the center of mass, say the x coordinate of center of mass. If I try to locate, I will say the first mass is dm, its x coordinate is x1. The second mass is also dm, same mass, or rather same value of numerical value of mass. Location of that mass will be say x2. Third mass is also dm, its location of mass is x3. Like that, you will have infinite number of masses divided by the addition of all the masses. Right? That's what we were doing so far. M1 x1 plus M2 x2 plus M3 x3 plus M4 x4 divided by M1 plus M2 plus M3 plus M4. That's what we are writing. Now the thing is, everyone, what we are writing at the top, I can take dm common and I can say x1 plus x2 plus x3 like that up till xn. And similarly, I can do the same for dm taken common, and you will have basically all the masses added in the denominator, dm plus dm like that. So in the numerator, everyone, we can write the expression of summation like this, that it is summation of x values varying from 1 to n number of masses. Similarly, summation of all the dm masses, right, everyone? So when we write this, or even if you take dm inside, because dm is also going to depend upon x, so you can write this part as summation of x into dm, where x value is going from 1 to n. So you remember that when the changes are so small, the values are so small, these summation signs are represented by the integration sign. So this is basically going to become integration of x dm divided by integration of dm, and this is how you'll be finding the x coordinate of center of mass. If you're talking about y coordinate of center of mass, the formula will have y dm upon integration of dm. For z coordinate, it will be z dm upon integration of dm. This is mathematical explanation of how the center of mass will be located for a continuous mass system. Let me try to give you a feel of this thing, okay, everyone? And what I'm about to tell you is what we call as the biscuit theory, what I call as a biscuit theory. I call it the biscuit theory. Try to listen to this. I try to give these random names to the explanation so that it becomes interesting, first of all. Secondly, whenever later in physics I try to recall or I want to make you people think about what I'm speaking about, I'll only use the word biscuit theory and you'll be able to recollect what is biscuit theory and what is the theory inside it. Okay. For this, we will be speaking about an example. And before that, let me just show you how the x, y, and z coordinates are written in the same manner. Integration of all these things. So basically, this integration of dm is basically going to give you the total mass of the system. That means you can also write this part as x dm, and denominator will become the total mass of the body. Right? Summation of the entire mass. dm plus dm plus dm is the total mass of the body. So similarly, x coordinate, y coordinate, z coordinate. The formula is not important, as in it is important, but how this is coming is not important. Rather than the feel of it is what I'm going to give you is the one which is very important. Okay, people. So pay attention. So everyone, just visualize a packet of biscuit. Okay, this is being seen from the top. This is a packet of biscuit which is seen from the top. Okay, what's the packet of biscuit? Let me make it a little smaller. Okay, so this is our packet of biscuit. Now, in this packet of biscuit, guys, imagine this is more like a those Britannia biscuits where you will have the there is a packet inside it. There is a plastic casing on which the biscuits are placed, right? So this is a case on which you place the biscuits. So basically, we are trying to find out the center of mass of the entire packet of biscuit, but we are actually disintegrating it. We are basically thinking about the process of formation of this entire packet of biscuit and how the center of mass changes when different pieces of biscuits are placed. So everyone, when the biscuit packet must have been formed, when you are placing the single biscuits over the entire packet of biscuit or the packaging, the first packet of first biscuit you can place anywhere. You can place anywhere the first biscuit. Say the mass of that biscuit is dm and its location is x. Okay, this biscuit, the quality of this biscuit is that it is very thin. Means what? Wherever this biscuit lies, its own center of mass also lies where the biscuit lies. It is that thin. Listen to me very carefully. Okay, it is that biscuit which is very thin, and where it is placed, its own center of mass. There are no other there are no other biscuits right now. So wherever this biscuit is placed, the center of mass of the biscuit is also there. Okay, that means at this point of time, x is the location of center of mass of the packet of biscuit, which is right now empty. Only one biscuit is left, or one biscuit is placed. Right, everyone. If I will place another biscuit, I have the freedom to place it somewhere else. Right, but obviously of the same mass, obviously of the same thickness also, right? So thickness of the biscuit is dx. All the biscuits have the same thickness, same mass. You have seen this quality of the biscuit packet. But now everyone, I'll have to call the first biscuit to be located at x1, the second biscuit to be located at x2. But now my question is, where the center of mass is lying? Is it lying on x1 or is it lying at x2? Or is it lying somewhere between x1 and x2? Everyone, it is somewhere between, right, everybody? Now let me place the, only when I'm asking you respond, otherwise please do not. If I place another biscuit somewhere here, what is the mass? Still dm, still same thickness, and the location is x3. Now the center of mass will be somewhere between the first mass that you see and the last mass that you see. Are you guys getting? Initially, the center of mass was here, then the center of mass was here, and maybe the center of mass is here. You see that movement of center of mass is happening? Can I say that once all the biscuits will be placed on it, there will be a final location of the center of mass? If all the biscuits are symmetric, in this case, probably the center of mass will be at the midpoint. We don't care about that right now. But are you guys able to see that we are starting with the very first biscuit? We are starting with the very first biscuit. And when you try to write the center of mass of that first biscuit, you will say its mass is dm, its location is x, divided by the total mass of the system. And you just integrate this. This is what is the result that you were seeing before this. Are you getting? In the numerator, try to visualize this as the single biscuit ka center of mass. Single biscuit ka center of mass. The mass, its location, divided by the total mass. So you are going to just integrate this by placing more and more and more and more biscuits. When you keep on placing all the biscuits, the entire packet of biscuit is formed, and you will be able to find out the location of center of mass. Okay, everyone? ठीक है? Feel आ गई कि फॉर्मूले में हो क्या रहा है? अब इसके बेसिस पे now we are going to see some objects and how do we find their center of mass. ठीक है? Shreyansh, that's what is going to happen. Okay? Cool. It started with one biscuit. This method that you are going to see now. Now I'm going to take actually this example for the center of mass of a rod. Now I'm going to talk about the center of mass of the rod. So guys, if this pen is a rod and if this is uniform in terms of density, अगर इसकी density uniform है तो center of mass कहाँ पे आना चाहिए? Where should the center of mass be if this rod is uniform? Exactly at the midpoint. We are going to prove that obvious thing. We are going to prove that obvious thing, and this process we will learn how this application is done. ठीक है? Everybody's ready? Right, everyone? You will see as we progress, the shape of the biscuit will change. Okay? Cool. Okay. Yes, Amrita, absolutely. Okay. So then the center of mass in star is in the center, right where the heaviest element will be. Hannah, if density is not uniform, you can actually not predict where the center of mass will be. Then you'll have to mathematically find it. Okay. Chale, everyone, so switching off the chat. And Gauri Shankar, I will answer that question in some time. Okay. So everybody, this is what we're going to do now. We're going to find out the center of mass of a rod. We already know the answer. We already know the answer, L by 2. Okay. So its left end is at x equal to 0. Its right end is at x equal to L. So this is to be seen like a packet of biscuit, and it is still not formed. Abhi packet of biscuit bhara nahi hai. It is only the casing, and I'm placing the first biscuit. This is my first biscuit. Its mass dm, its width dx, its location x. Same as I told you guys earlier. Okay. Now, people, there is one information which we will assume if it is not given. We will assume that it is uniformly dense. And I hope, guys, I gave you this idea of mass densities a few days back, right? Mass upon length, mass upon area, mass upon volume a few days back. So this is mass upon length called as linear mass density defined for 1D objects. Okay, thank you. So this is mass per unit length defined here, and this is defined to be a constant. Mass of the object divided by its length is a constant. So what is the beauty of mass density is that if this is constant for the entire rod, It will be same for half the rod, it will be same for 1/4 of the rod, it will be same for 1/10 of the rod, it will also be same for this small biscuit. Whatever be the density of the entire packet of biscuit will also be the density of a single biscuit. So single biscuit के लिए लिखने जा रहे हैं, the mass of the entire rod is m, the length of the entire rod is capital L. Similarly, the mass of the single biscuit is dm, and the length of the single biscuit is dx. Okay, guys, that's the beauty. Mass per unit length valid for the entire rod, valid for a single biscuit also. So from here, I can write down dm as m by capital L into dx. From here, we have got dm in terms of rod ka mass and capital L. Capital M is constant. Capital L is obviously constant. The mass and the length of the object are constant. Now, people, I will try to write this to find out the location of the center of mass. Okay, people, so pay attention. So the x coordinate of center of mass is going to be integration of x dm divided by integration of dm. What is x? X is the location of the first biscuit. What is dm? You will replace it here. When you replace it, it becomes m by L dx. Simple. Divided by integration of dm. Should I also put it here? You can, but you can actually directly say that this integration of dm is basically adding all the mass of the biscuits. All the biscuits that you will place here, they all will have mass dm, all the dms when you will add. Can I say that you will get the mass of the entire rod if I add all the dms? Right, everyone? So I will directly write plus m. I don't have to integrate it separately because I'm sure it's going to be the total mass of the system. So everyone, from numerator, m by L comes out of integration because it is constant. Okay, everyone, m by L is a constant. We do not integrate a constant. Something which I can again recommend to you people to revise the chapter of calculus where I've taught you in the beginning if you have not done it already. Okay, divided by this mass m, and I'm left with only x and dx inside. Okay, now the interesting part and the part which will be something that you'll have to keep a note of later on if ever you deal with a rod. This is how things are going to be. So everyone, first of all, you see m and n got cancelled, and now for x dx we have to always in such cases do a definite integration. That means I need to know the limits of integration, and limits here is dependent upon this quantity I'm integrating. I'm integrating x. So everyone, I'm asking you all, what is the minimum value of x, or where exactly the least value of x that I can put the first biscuit on? मैं सबसे पहले biscuit कहाँ रख सकता हूँ? सबसे left वाला point क्या है? Can I say it is 0? And what is the rightmost end? What is the rightmost end? The location. Let's call it capital L. Right, everyone? I can place the biscuits to form this rod or the biscuit packet between 0 to capital L. Do you understand? This is practical application of definite integration happening in front of you right now. Okay, everyone. Now, what is the integration of x dx? This is something which is absolutely easy. After this, you have nothing to do. I don't know whether you guys remember it or not. I'll say this after some time. 1 by L, integration of x is x square by 2, and you will have to put the limits from 0 to L. You will get the limits 1 by L. Put the upper limit, you will have L square by 2. Put the lower limit, that is 0, you will get 0. What is the final result? L square by 2L, L get cancelled, L by 2 as we expected. The location of center of mass. Right, everyone? If you people remember, I might have said this when I taught you integration for the first time, that it is not integration which is difficult. It is actually making the equation that I need to integrate. That is challenging. This is easy to integrate. X dx is like bachpan ka integration now. But what is difficult is to form this equation. Getting my point? In physics, this is what will bother many students. I'm giving you a heads up. So always whenever integration is done, pay extra attention to the class, to the teacher, and do watch the replays of the session. Okay? Exactly. Due to the uniform rod, the center of mass came at the center. Okay? Okay, Hriday, aayega samajh mein. Relax. So this is the result of location of center of mass. What will be the y coordinate of center of mass? Can anyone please tell me? The y coordinate will be 0. Z coordinate will also be 0. Thank you. Exactly. So the location of center of mass is L by 2, 0, 0. Okay? Exactly. मेरे सारे students in my previous 11 years of teaching remember finding the location of center of mass by biscuit theorem till date. Okay? Of biscuit theory it is. Okay? विहान आज तुम्हारा माइक्रोफोन नहीं चल रहा है by the way. Ansh, totally your call. Okay? Means the location of center of mass of uniform rod is mass independent. Absolutely not. Siddharth and everyone else, अगर इस length, इस rod का length 1 meter है, तो center of mass का location कितना, क्या location होगा? Everyone, what will be the location of center of mass? 0.5. But if the length of the rod becomes 2 meters, then the center of mass will be at 1. So that's how it is dependent on mass, and it is dependent upon the length also. समझ गए? Yes. Okay, चलो बाद में appreciate करना, अभी आगे बढ़ते हैं. Okay. सादिक, we do not speak about center of mass of spring in our syllabus. मैंने जो बोला था वो ऐसे ही डाउट्स के लिए बोला था. मैंने ऐसे ही डाउट्स के लिए बोला था. जितना बताऊं उतना ही समझना, उससे ज्यादा मत समझना, उसको और डाइवर्सिफाई मत करना, कन्वर्ट करना, तो समझ पाओगे और रिटेन कर पाओगे. समझ तो अभी भी गए होंगे, पर इसको रिटेन करना इज द मोस्ट चैलेंजिंग टास्क. एवरीबॉडी. Yes. Audible, but can you speak a bit louder? Yes, tell me. Are you new to the batch or have you been regular in my class? So you'll have to go through my lectures of vectors and calculus. Then maybe you will be able to understand this better. Okay? Cool. Okay, guys, let's continue. We have more biscuits packet to form. The same rod is now bent in the form of a semicircular ring. But before I speak about the semicircular ring, can you please tell me if this was a complete ring, where will be the center of mass? Uniformly dense, obviously. If I will have a complete ring, what will be the location of the center of mass? The center of the ring, right, everyone? The center of the ring. So I'm cutting it half. Where will the center of mass shift? Where will the center of mass shift? Mass shift now. Up. Can I say if it is xy plane that you see the body in, the x coordinate of center of mass will be the x coordinate of center of mass will be same, but what? If center of the ring is 0, 0, if center of the ring is 0, 0, what is the x coordinate of center of mass? Same, 0. But y coordinate will not be 0 anymore. So we want to find out the location of center of mass of the rod. And now everybody, your same packet of biscuit has taken a semicircular shape. Your packet of biscuit has become semicircular now. Very interesting. Okay, so listen to the part that I'm explaining and try to pay attention. This time you will consider the similar way that your first biscuit is placed somewhere here. Okay, everyone, I'm placing my first biscuit somewhere here. What is the mass of this biscuit? dm. What is its length? But before that, the angle which is subtended by the biscuit, this is how we speak about this kind of discussion. Okay, the angle which is subtended by the biscuit on the center of the diagram is very small angle, and that small angle is called as d theta. The location of this biscuit dm is found angularly. You define this angle to be theta. That means what? If I put my first biscuit here, the angle will be 0. If I place my biscuit here, the angle will be pi by 2. But if I place my biscuit here, what will the angle be? It will be pi. Are you guys getting it? Like that, if I keep on placing the biscuit at different locations, the value of theta will change. Okay, so this time I'm not going to define the location of my biscuits on the basis of x, rather I will define them on the basis of the angle which is subtended by their positions. Okay, part to remember. Okay, now the other interesting part. This dm mass can be seen, if I magnify it, I can see it like a giant circle ka arc, means something of this sort. Okay, so this is my arc which I'm considering as dm. So this is dm. So I have zoomed this part. Okay, everyone. So this thing is drawn here. So everybody, you know that this length is going to be the radius, this angle is going to be d theta, and this is your center O. So we know that angle is defined as arc length. Arc length I'm interested in finding. So arc length divided by radius. So arc length, which is basically the width of the biscuit, comes out to be r into d theta. Means what? I've got this length value. How much is this arc length? It is r d theta. Okay, everyone. So when you start talking about rings, you start defining the location of the biscuits in terms of theta, and you start writing the width of your biscuits, not as dx. You start writing them as r d theta. Okay, r d thetas are going to be the width of your biscuits. Always means till the time you will be completing your physics with me, you will see this is how for a circular portion the biscuits will have their arc length as r d theta. Iska application dekho. So everyone, this is how we'll be finding the location of center of mass. And everybody, if we are calling this angle to be theta and this is r, see that a right angle triangle is being formed. I'm just going to write or draw this right angle triangle here. You see that this is r, this is the x coordinate. I'm basically talking about my point mass which is placed here. This is where my biscuit is. Okay, this is where the biscuit of mass dm is. So this is its x coordinate, this is its y coordinate. And I'm concerned with the y coordinate because I'm only interested in finding the y coordinate of center of mass, because I already know that the x coordinate of center of mass is going to be 0 because of the symmetry. Okay, so people, if this is angle theta, can I say on the chat box y is going to be r sin theta? This is going to be r sin theta. Though I can also write down x as r cos theta, but it is useless for us right now. X is r cos theta, but useless for us. Okay, dm is the mass and width is r d theta. Manan Chaudhary, width is r d theta. Width is not even dx now. That's what is the part. इसलिए बोला ध्यान से सुनते जाना जो भी बोल रहा हूँ. Okay, now people, interesting part. It is still a 1D object. It's the same rod which is converted into a semicircular ring. The rod is converted into a ring. That means what? You define lambda, the mass density, and the only part is this time the mass is capital M of the rod, but the length is not L. Can you people tell me the length of this rod, which is given a shape of semicircle? 2 pi r ka half of the circumference. So can I say pi r is the length? Right, everyone? Length of rod L is pi r. Correct? Awesome. Very good. And everybody, the small biscuit mass is dm. Can you tell me its width? What was the width we found? Exactly, it is r d theta. Okay, everyone. This width, okay, AB. Let's call it AB. Okay, arc length AB. AB is r d theta. Perfect. So you see, I'm just repeating one more time. The mass of the entire rod divided by the length of the entire rod. Mass of the biscuit divided by the length of the biscuit is what we have written. Kuch cancel ho raha hai? Bilkul ho raha hai. R and R are getting cancelled. Let's continue. From here, we can write down dm. This d theta goes to the left hand side. M into d theta divided by pi. That's the mass of the small biscuit. This time I'm getting in terms of capital M. Okay, everyone, switching off the chart so that you pay attention. So everybody, now we'll use the formula of center of mass allocation, which is integration of y dm divided by integration of dm. So y coordinate is r sin theta. What is y? This is y coordinate. So integration of y, which is r sin theta, into dm divided by total mass, that is capital M. Now I will be placing this dm here. Okay, are you all with me so far? I've placed y coordinate r sin theta already. Okay, because as my biscuit ka location changes, okay, as my biscuit ka location changes, the r sin theta value also changes. That's why. Okay, so let's integrate this. Cool. Switching off the chart so that we all focus. Y coordinate of center of mass. From here, continuing, I see that capital R is a constant, capital M is a constant, and first I will write it as it is. That it is r sin theta dm divided by m. So r by m integration of sin theta, and what was dm? Dm is m by pi into d theta. M by pi into d theta. So what else comes out? R m by pi m. So m will get cancelled. Now you see, simplest of the integration that you can ask for. Sin theta d theta is the integration. But the limits. What is the minimum angle which will be formed when I place the biscuit on this bracket? 0. And what is the maximum angle that can form when I'm placing the last biscuit? 180 degree or pi. I can write it as 180 degrees also. But 0 to pi is the limits of integration. Lovely. So r by pi, sin theta integration is minus cos theta. If you have revised, you would remember. Okay. So see this, guys. First putting the limit, upper limit, cos of pi, and minus minus plus cos of 0. Can you tell me the bracket value directly? I expect you people to tell me the value of the bracket directly. Bracket का value पूरा. Cos pi is -1. Already a minus is waiting outside, so will become +1. Cos 0 is also 1, so 2 is what I get outside. So the y coordinate of center of mass comes out to be 2r by pi, and that is the result that you need to remember. Okay, 2r by pi. So slightly ऊपर उठ जाएगा is no more the answer. Center of mass will lift slightly upward is no more the answer. This is the amount by which your center of mass will lift. Okay, the location of center of mass. Now you will not call it 2r by 180. Why will you not call it 2r by 180? Because 180 degrees. Degree is not SI unit of angle. You always speak with respect to SI units. Okay, cool. That is why I said around 30 minutes back, you need to watch the replay of the session also. Okay, everyone? Yes. So the location of center of mass that we have found here, this location is 2r by pi. This is what we have found just now. Okay, everyone? What to remember? The final result, 2r by pi. Okay. Prateek, if I will cut a ring, if this is the ring, and I will cut it like this. So earlier, the center of mass of the entire ring was at the center. If I will remove the lower half of it, will there be any change in the center of mass location? You mean to say that center of mass will still be here only? Then why only upward? Why not left and right? Why not left and right? Tell me your thoughts. That's okay. Because of symmetry, right? That is why the x coordinate is 0. Okay. Captain Arshad, who's taking the class? Me or you? Huh? Who's taking the class? Who's the master teacher in the class? Me or you? Huh? I don't need these reminders. Remember that. I don't need these reminders. My track record says that if I say something at the beginning of the session, I always keep my promises. Okay? Or track record के accordingly बोल रहा हूँ. I said we may be able to see that part. And right now it's 9:43. Doesn't look like we will be able to. Okay? If you guys are ready to extend the class with me for half an hour, we'll be able to give you guys that. Okay? ठीक है. Vishak, you will have to watch the replay, the PDF part. You will be able to see the derivation once again. That's not important anymore right now. The derivation is not important. The result is. Okay? Chalo, everyone switching off the chat so that. Let's speak about the semicircular disc, the last derivation that we'll do today. After this, I will directly give you the results that you have to remember. Derivations are actually not important. I'm just giving you the derivations of few objects so that you understand how integration is done. My objective is actually not to show you the derivations of all the center of mass. Center of mass derivation is not the objective here, honestly speaking. The intention is actually to give you the feel of application of integration. Now, everyone, this time what you see is a semicircular disc. Okay, so if we had a disc like a CD, like a pizza. So if you have entire circle, the center of mass will be also at the center, right? Just a second, like this one. So if we speak about a disc, the center of mass is also going to be at the center of the disc, right? It's a T-coaster. So if I, by any chance, able to cut this half, if I'm able to cut this exactly half, again the center of mass will move up by some distance on y-axis. There will be no change in the x coordinate. There will be no change in the z coordinate also. So this time we are going to define mass per unit area. We are going to define mass per unit area. But more than that, I'm going to show you guys that how the biscuit theory works here. Okay? अगर आज ये भी समझ गए ना तो क्लास सफल है और आगे का पार्ट हम आज नहीं भी करेंगे तो भी क्लास सफल है. Okay? So let me find that absolutely stunning thing that you guys will get the feel of integration in. What I'm trying to say, the biscuit theory that you all are going to remember it by. Just trying to find that. So everyone, when we speak about a disc, this has to be a biscuit, a packet. This disc is also a packet of biscuit. The interesting part is the shape of the biscuits. And let me show you, this becoming a biscuit packet with biscuits inside will look like this. Not exactly the diagram shows you the circular ones, but I hope you all know this is a mosquito repellent coil. And this is the best example that I can show you to give you a feel of how the disc is made up of so many small biscuits. Are you guys able to see that it is actually made up of small rings? Those rings are actually forming a disc. Are you guys getting it? Right? So this is the kind of situation which we are going to create when we are going to do the derivation. See this, everyone. This is basically your first biscuit. Then you will have a bigger biscuit. Then you will have a bigger biscuit. Then you will have bigger biscuit, bigger biscuit, bigger biscuit. What is happening? All the biscuits are basically rings. All the biscuits are ring, right? But as you are putting the biscuits one by one, the size of the biscuit is increasing. The radius of the biscuit is increasing, right, everyone? Then only I'll be able to form a disc. Then only I'll be able to form a disc. Maybe you'll be able to visualize a bit here also. These different shapes of rings that you see here, they are all biscuits, and they are forming a disc. Getting my point? Everyone? Got the feeling? Cool. So that is why when I cut it half, everyone, when I cut it half, those who will actually, onion ring is also a beautiful example. Thank you, Harshan. No, not Harshan, but Hridaya. Yes, actually, onion rings. If you will cut an onion in the form of a circle, absolutely lovely example. Next time onwards, I'll actually show the example of onion in that case. Onion cut in the form of disc, all those small rings which are formed inside, they're forming a disc. Absolutely amazing example. Thank you, Hridaya. Thank you. Great example. So everyone, this is how my biscuit is going to be, a randomly chosen biscuit. The first biscuit is placed randomly here. Okay. So the mass of this biscuit is dm. Okay. The mass of this biscuit is dm. And the point is, now my biscuit is the first biscuit that I'm placing. Forget about the gray diagram behind. Just focus on the blue strip. The radius of this blue strip is small r. Okay, everyone, the radius of this blue strip is small r. So guys, if only focusing on the blue strip whose radius is r, what will be the center of mass of the strip? Will it be 2r by pi or not? The location of center of mass of the strip. It's basically a semicircular ring, right? We have already done the derivation of that. So now I know that all the rings that I'm going to place, they will have different values of r. They will have different values of r. But as the r will change, their individual center of mass will also change. But the formula by which I will be able to find their center of mass is 2r by pi. Are you guys getting the feel of it? Right? Cool. Awesome. So now everybody, now when I'm going to do this, I'm writing mass divided by the area. What do we call this? This is mass per unit area. So mass of the semicircular disc is m. The area is pi r square by 2, half. Pi r square का आधा. ठीक है? So 2m by pi r square. This should be equal to dm biscuit का mass divided by उसका area. अब ये वाला पार्ट तुम्हें बहुत अच्छे से समझना है मेरे साथ, और आज समझ लेना तो पूरे 2 साल काम आएगा, उसके बाद भी काम आएगा. ठीक है? Everyone, so pay attention to this part. Everybody. If you think of, just a second. Okay. So everyone, I have a semicircular ring whose radius is r. Can you people tell me the length of this? Can you tell me the length of this thing? Will it be pi r? Correct? Pi r. Perfect. Let's say its thickness is dr. Let's say its thickness is dr. Okay? Its thickness. You understand the thickness, right? Mortine coil ki thickness. This thickness I'm talking about. This thickness I'm talking about. This is dr. Right? So for a moment, be with me. Make it a straight rod. Again, let's make it a straight rod once again. Okay? We are making it a straight rod. Okay? And we will zoom it also. Zooming it a bit. Everyone, pay attention. What is the length? Pi r. Right, everyone? The length is pi r. The width is dr. Right, everyone? Do you see right now in front of you? This is a rectangle. Right, everyone? Can you tell me the area of a rectangle? It's length into breadth. Length is pi r. Breadth is dr. Okay? That's the area of the ring. That's the area of the ring. But very important to understand which area we have talked about it. Okay, everyone? If this would be complete ring, it will be 2 pi r dr. ये बहुत important चीज है तुमने सीखी मेरे साथ. Please keep this in mind, everybody. The pi r dr is for semicircular ring. If this would be a complete ring, the area would have been 2 pi r dr. Okay, everyone? So let me write down this here. The area for this will be 2 pi r dr. Explanation on the next slide for all of you. Pi r into dr, not 2 pi r, because this is semicircular ring. Yeah, तूने लिखा, बिल्कुल correct कर दिया. Pi r dr. Okay, now focus here. Can I write dm as pi got cancelled? 2m r dr divided by r square. Are we all getting this? This is what you are also getting. 2m r dr by r square. Pi, yeah, exactly. Cool, awesome. Now we have dm and we want to locate the center of mass. Cool. Shall we switch off the chat? The denominator part is already capital M. In the numerator part, dm is found already here. This is dm that we need. Okay, so this is the dm part that we are going to need. Okay, so dm की जगह पे we will be placing it here. So instead of dm, I'm writing 2m r dr by r square. 2m r dr by capital R square integration. Already y is waiting, and y will be placed as 2r by pi. ये 2r by pi कहाँ से आया? उस ring का center of mass है. The center of mass of the ring. This is what is y coordinate of center of mass of the ring. Okay, everyone. So we have this. Now see, the constants will come out. M gets cancelled. 2 into 2 is 4 by pi r square integration of r dr. Now people, what is the minimum value of this biscuit that I can select at? This is where I can place my biscuit. So what is the minimum radius? 0. And what is the maximum radius that I can take it to? Capital R. Center से लेकर circumference तक. Good. And r into r becomes r square, by the way. This is r and this is also r. What is the integration of r square? So 4 by pi r square integration is r cube by 3. Put the limit from 0 to capital R. You will have 4 by pi r square into r cube by 3. Final answer. R square cancels r cube. I have 4r by 3 pi as the final result of location of center of mass of the semicircular disc. Okay, everyone? Okay. These are the results we have derived. These are the results that you will remember. I will ask you people to memorize. Very rarely you will see me asking you to memorize something, but this is one of them. You have to remember. Okay. This was the most difficult part. If you understood the discrete theory, you would actually be able to get the feel of integration in general. In general, I would say. Okay. The replay बिल्कुल देखना होगा, absolutely, no doubt on that. अब इनका यूज कैसे होता है ये बता दो. Why did I ask you people to not bother yourself much about the process of integration? Listen to me carefully. Why the integration part is not going to be very useful? It is useful in terms of understanding integration and application, but why the derivations are not important? Because the kind of questions that you will get will give you the shapes of the object and will ask you to find out the center of mass of combination of the objects. There are two types of questions which they ask in center of mass. Okay, listen to me everyone. They will give you say a disk, they'll give you say a square, just an example, and they will ask you to find out the location of the center of mass of the combination. Okay, so you will say that the center of mass of the ring will be here. तो मान लो अगर ring का shape जो है, say its radius is r. Everyone, try to be with me. If the radius of this circle is r and the shape of this thing has radius, the length is l. So can you people give me the coordinates, the x coordinate of center of mass of the ring or disk? It's going to be r, right everyone? Center of mass of the disk. Maybe its mass is m1. Maybe its mass is m1 or md. You can call it md also. Let's call it m1 only. And the center of mass of the square. Can you people tell me the location of center of mass? Yes, that is where the interesting part is. You have to travel 2r and then you have to travel l by 2. So the location is 2r plus l by 2. Exactly. 2r plus l by 2. So this is x1 this is x2. And now if you have to locate the center of mass, what will you do? m1 x1 plus m2 x2 divided by m1 plus m2. That's it. वही formula, पुराना formula. तो तुम ऐसे find out किया करोगे. If you know the location of center of masses already. Okay? Got it? ठीक है? तो चलो एक क्वेश्चन करके बताओ मुझे. एक क्वेश्चन करके बताओ. अरे यार ये पूरा लेंथ l है तो ये हाफ ही है ना उसका, l/2 ही तो होगा. ये आधा ही लेंथ हुआ ना. यहाँ से यहाँ तक l/2 नहीं होगा क्या? ठीक है? Absolutely. Don't worry, I will give you the formula. अरे राजकुमार ये ओरिजिन है, ये है 0,0, तो सेंटर ऑफ मास r डिस्टेंस आगे आ गया ना. चलो एवरीवन. So this time you have to find the center of mass of a uniformly dense object. अच्छा uniformly dense object है, ठीक है. तो तुम्हें hollow नहीं, solid हेमिस्फीयर की जरूरत पड़ने वाली है. Solid हेमिस्फीयर की जरूरत पड़ेगी और solid कोन की जरूरत पड़ेगी. Solid कोन का center of mass है h/4 पे. Okay, so this is h/4. If height is h, the center of mass of the cone is at h/4, and if it is semi solid sphere, okay, then it will be 3r/8. So height is given from this level. The height is given to be 3r, and the radius of the hemisphere is given as r. You have to locate the center of mass. I am just giving you people some time here. You guys start solving. After 1 minute, I will start the quiz. Only thing that I'm telling you people is this part is positive y and this part is negative y. So the y coordinate of center of mass for the cone is positive, while the y coordinate of center of mass for the hemisphere is negative. And then you have to apply m1 y1. Take a minute. Stop writing. Stop solving. Stop solving. Don't solve. This will be very lengthy. This will be very challenging. Okay. Why? Because mass is not given. It is given that both of them have uniform density. So please pay attention for 5 more minutes. We will not extend beyond that. Okay. So let me define the upper half of the cone, which is the upper half has mass m1 and sphere has mass m2. Please pay attention. So for cone, the mass m1 will be density into volume. Okay. So density is same. Volume of a cone is 1/3 pi r square h. Pi r square h, and h is 3r. H is 3r. Okay, everyone. So 3 and 3 get cancelled. Okay. Is it visible now properly, everyone? Is it properly visible? Okay, fine. Now, switching off the chart. So, I'm writing the mass of the first cone, first object which is cone, second object is hemisphere. Mass of an object is density into volume. Its density is rho, and volume of a cone is 1/3 pi r cube, assuming that you know this. This 3 and 3 get cancelled. I get the mass value as rho into pi r cube. Okay, this is m1. Similarly, m2 for hollow sphere, hemisphere, is density into volume once again. But the volume for a sphere is 4/3 pi r cube. This will be 2/3 pi r cube. Why? Because it is hemisphere. Not 4/3, but 2/3, because half of the volume will be there. Okay, everyone. So guys, can I say that if this mass is m, then here the mass of the sphere is 2/3 m. Do you guys follow this part? अगर कोन का मास m ले लेता हूँ तो स्फीयर का मास उसका 2/3 टाइम्स दिख रहा है. सब लोग दिख पा रहे हैं? Except this part, rho into pi r cube is basically the same part. Okay. So now I'm going to proceed with the mass value already known. Mass m1 is m. Mass m2 is 2/3 m. The location of center of mass are already known to me. So y coordinate of center of mass is going to be m1 y1 plus m2 y2 divided by m1 plus m2. So m1 is m, and the location of center of mass is h/4. h/4 is basically 3r/4. That is the height, right? So 3r/4. Okay, and for this is 3r/8 only because it is in terms of radius. ये बात समझ में आ गई सबको? H value is 3r, so h/4 becomes 3r/4. So this is 3r/4. For the sphere, mass is 2/3 m. M2 is 2/3 m, and it is negative y side. That means minus 3r/8. Okay, everyone? 3r/8, but this time the sphere is downward, which is on the negative side of origin. So that's why minus 3r/8. Total mass is m plus 2/3 m. Okay, so everyone, this is 3/4 mr minus 3 and 3 got cancelled. 2 cancels it 4 times, minus mr/4 divided by 5m/3. So what am I getting? I'm getting 2mr/4 divided by 5m/3. M cancels, 2 cancels is 2 times. I have r/2 divided by 5/3. 3 goes in numerator, 2 comes down. I have answer as 3r/10. That's my answer. Okay, everyone? Got it? So welcome to JEE preparation. Before we end the session, a simple quiz just to test your memory. Just to test your memory. For a semicircular ring, if it is placed like this, what is the y coordinate of its center of mass or its center of mass coordinate? Your time starts for 15 seconds in 3, 2, and 1. Answer it. Oh. memory based question था, should have been 100%, but नहीं आया. Y coordinate is 2r/pi. Remember it, everyone. Okay. तो यहाँ पे हम क्लास का theory end कर देंगे आज. Okay. So everybody switching off the chat so that you see the leaderboard आराम से, इत्मीनान से. Congratulations to those who are here in the leaderboard. But today's session is not about the leaderboard at all. It's not about the leaderboard. It is about understanding the session. Okay, Captain Arshad, 2 minutes रुक जाओ. ठीक है. Removing the leaderboard in 3, 2, and 1. Showing you astronaut now. Okay, good job, good stamina. Okay, important information for all of you. The class is officially over. Those who want to exit can exit. Class teachers, when you're done with your doubts, you can also exit the class. Now the session will be open for the discussions. Okay. क्या मैं समझ नहीं पा रहा हूँ क्या कहना चाह रहे हो डाउट क्या है क्यों भाई अच्छी बात है टीचर से थोड़ा डरना भी चाहिए ये जेनरिक वे में बोला मैंने क्योंकि अगर मैं ये सवाल अब सबसे पूछूं कि क्लास कितनी समझ में आई तो आई थिंक 60% लोगों को क्लास समझ में आई होगी प्रॉपर्ली 40% लोगों को एक्चुअली रिप्ले देखना पड़ेगा आई हैव डन अ लॉट ऑफ मैथमेटिक्स एंड आईटी कैप्टन अर्शद बाद में बात करते हैं लेट्स टॉक एट द एंड ऑफ द क्लास व्हेन एवरीबॉडी इज आउटसाइड डन ओके ठीक है हाँ भाई आओ मित्रों ओके दैट्स गुड कैन यू प्लीज अनम्यूट मी चलो समर्पिता से शुरू करते हैं आज हाँ समर्पिता विदाउट एनीथिंग हियर एंड एनीथिंग हियर डायरेक्टली कम टू द डाउट कांट हियर यू समर्पिता आवाज नहीं आ रही कुछ नॉइज आ रहा है नाउ यू आर ऑडिबल टेल मी इसीलिए हेडफोन हटा दिया करो हाँ ठीक है बोलो स्लाइड नंबर 12 पे चलते हैं बाकी लोग भी ध्यान से देखना यार तुम्हारे डाउट के आंसर हो जाए तो जबरदस्ती अनम्यूट मत होना हाँ यस यहाँ क्या सेम कोऑर्डिनेट्स ऑन एक्स एक्सिस ओनली तो कोई बात नहीं उन सबको भी लिखते जाएंगे मतलब तुम बोलना चाह रही हो कि एक ही जगह पे मान लो 1 kg भी रखा है 2 kg भी रखा है 3 kg भी रखा है और सबका कोऑर्डिनेट है 1 मीटर और बाद में आगे और भी होंगे तो एक्स कोऑर्डिनेट लिखा जाएगा 1 × 1 प्लस 2 × 1 प्लस 3 × 1 और भी जो भी है डिवाइडेड बाय द मास ऑफ 1 + 2 + 3 जरूरी नहीं है सबसे अच्छा तरीका तो होगा सबके मास को ऐड कर दो क्योंकि सबका लोकेशन सेम है क्योंकि सबका लोकेशन सेम है इसलिए ऐड करके टोटल मास 6m को लिखो डायरेक्टली ज्यादा अच्छा होगा लिखना चाहिए ज्यादा टाइम बचेगा ज्यादा एफर्ट्स बचेंगे इसलिए 45 ओके हाँ डिस्क वो एकदम सेंटर ऑफ द डिस्क पे होगा जीरो एक्चुअली वो जीरो समझने के लिए जीरो है क्योंकि मैं बेसिक थियरी के हिसाब से बता रहा हूँ द स्मॉलेस्ट ऑफ द रिंग विल बी ऑफ जीरो रेडियस द लार्जेस्ट ऑफ द रिंग विल बी ऑफ रेडियस इक्वल टू कैपिटल आर नहीं एक्चुअली जीरो मतलब इंटीग्रेशन में हम एक्चुअली लिमिट ऐसे लेते हैं तो इसलिए ये क्वेश्चन जैसा मैंने बोला ना ये जो किया हमने डेरिवेशन ये अपने प्रोसेस है जो हम सीख रहे हैं कि कभी भी आगे जाके भी हम बहुत सारी बार रिंग डिस्क इन सब के इंटीग्रेशन करेंगे किसी और चैप्टर में किसी और क्वांटिटी के लिए यहाँ तो सेंटर ऑफ मास फाइंड आउट कर रहे हैं कभी और आगे जाके हम किसी और फॉर्म में रिंग और डिस्क से डील करेंगे तो प्रोसेस ऑफ इंटीग्रेशन ऐसे होगा उसमें जो डिस्क चूज करेंगे वैसे होंगे उनकी लिमिट ऐसी होगी अजीब है इसीलिए इसीलिए नया है इसीलिए नया है और इसीलिए बहुत अलग है और यहाँ से और इसलिए मैंने बोला कि यहाँ से ये दिस इज अ फीडर ऑफ इमेजिनेशन ये फीडर ऑफ इमेजिनेशन है सोचो सोचो ये जो आगे के ऑब्जेक्ट्स हैं जैसे हॉलो स्फीयर की बात करूं तो हॉलो स्फीयर कैसे बनेगा हॉलो स्फीयर पूरा का पूरा स्फीयर की बात करते हैं रिंग पूरी पूरी एक हॉलो बॉल है तो हॉलो बॉल कैसे बनेगी सबसे नीचे साउथ पोल पे एक रिंग इमेजिन करो जिसका रेडियस ऑलमोस्ट जीरो है उससे थोड़ा ऊपर आने की कोशिश करो तो रेडियस बढ़ेगा और ऊपर आते जाओ जब इक्वेटर पे पहुंचोगे तो रेडियस इक्वल टू द स्फीयर हो जाएगा अभी तो रिंग रखा हुआ है सारे रिंग्स हैं फिर वापस नॉर्थ पोल की तरफ जाने लगेंगे तो रेडियस साइज डिक्रीज होते चले जाएंगे तो बेसिकली ऐसे में हम रिंग की लोकेशन को 0 to 0 करेंगे तो सब कुछ 0 आ जाएगा तो हम उसकी एंगुलर लोकेशन बताते हैं कि सबसे नीचे वाली रिंग का एंगल जो है वो π/2 बनेगा 90 डिग्री और सबसे ऊपर वाली रिंग का एंगल बनेगा 90 डिग्री प्लस π/2 कैसे तो माइनस π/2 से प्लस π/2 जाते हैं उसमें इंटीग्रेशन जब हाँ हाँ हॉलो स्फीयर में अंदर मास नहीं है सिर्फ सरफेस पे मास है और सॉलिड स्फीयर में अंदर भी मास है लाइक एक रबर बॉल है और एक प्लास्टिक की हॉलो बॉल है जैसे बलून है हॉलो एक बलून बिल्कुल होगा सॉलिड स्फीयर में मास अंदर भी आ गया सॉलिड स्फीयर में मास सरफेस के अंदर भी एग्जिस्ट कर रहा है लेकिन हॉलो स्फीयर में मास सिर्फ सरफेस पे रखा हुआ है अंदर सिर्फ वैक्यूम है हॉलो स्फीयर में मास फिजिकली कहाँ है फिजिकली मास सिर्फ सरफेस पे है ना फिजिकली मास सिर्फ सरफेस पे इसलिए देखो लोकेशन ऑफ सेंटर ऑफ मास फॉर सेमी हॉलो स्फीयर जो है वो ज्यादा है r/2 का वैल्यू 3r/8 से ज्यादा है मतलब सॉलिड स्फीयर में मास सेंटर ऑफ मास नीचे शिफ्ट हो गया बिकॉज़ और भी मास अंदर आ गया इसलिए सेम वे में हॉलो कोन का सेंटर ऑफ मास और सॉलिड कोन का सेंटर ऑफ मास देखोगे तो सॉलिड कोन का सेंटर ऑफ मास नीचे है क्योंकि उसके अंदर भी मास है तो वो सेंटर ऑफ मास की लोकेशन को नीचे पुल कर रहा है ना okay अच्छा somebody asked me this question कि sir center of mass will always lie on the surface of the body or inside the body center of mass can lie outside the body also as we have seen today in the ring case only ring के केस में center of mass is not lying where mass is existing mass यहाँ exist करता है center of mass यहाँ कहीं आ रहा है बाहर बॉडी के बाहर है in fact ring खुद ring जो होती है the ring itself the mass is on the circumference the mass is on the circumference here लेकिन center of mass वहाँ आ रहा है जहाँ mass है ही नहीं so not necessary center of mass can be outside the body also it's an imaginary concept बिल्कुल नया है और बहुत जरूरी है समझना क्योंकि रोटेशन मोशन इसी पे डिपेंड करेगा सर व्हाई आर वी टेकिंग x इक्वल टू 0 आर यू ट्राइंग टू आस्क द क्वेश्चन फ्रॉम दिस पार्ट यहाँ से पूछ रहे हो रेडियस वाले पार्ट से अमन आदित्य थोड़ी देर में तुम्हें अनम्यूट करता हूँ ठीक है अमन ये समय बता यू कंटिन्यू एब्सोल्युटली दैट इज व्हाट इज नीडेड और अगर कभी-कभी अगर टाइम बाउंड में नहीं भी आंसर कर पाए दैट्स फाइन जब फाइनली तुम चेक कर रहे हो कि सर ने तो सॉल्व किया उसमें आंसर क्या आया अगर तुम्हारा आंसर उससे मैच हो रहा है दैट इज इटसेल्फ परफेक्ट ऑसम ठीक है गुड नाइट, बाय बाय। ओके, सबसे पहले मैं अमन आदित्य को ही अनम्यूट करूंगा। अरे अमन आदित्य, तुम्हारा माइक्रोफोन नहीं चल रहा यार। हाँ, ओनम, इज इट ओनम? ओनम है क्या आज या कल में? ओके अंश। हर्षन, वो बैलेंसिंग सिर्फ एक समझाने वाला पार्ट है, पार्ट ऑफ एक्सप्लेनेशन। वी विल नॉट बैलेंस ऑलवेज, राइट? ये सिद्धार्थ 30 39 मिनट्स। हाँ, सेमी सर्कुलर रिंग का सेंटर ऑफ मास यहीं तो इसी के बाद बताया था यार। किसको? ये वाला स्टेप? वो तो रिंग ही चल रहा है, तुम रॉड की बात कर रहे हो शायद। हम्म, क्या ना? हम्म, अगर सेम ऑब्जेक्ट है तो मास इंडिपेंडेंट है। लेकिन अगर तुम शेप पे जाने लगोगे कि सर अगर कभी भी कोई भी रॉड है तो उसका सेंटर ऑफ मास L/2 होगा। हाँ, L/2 होगा, लेकिन अगर लेंथ चेंज होती गई तो लोकेशन ऑफ सेंटर ऑफ मास भी चेंज हो जाएगी। दैट्स व्हाट आई मेंट। तो अगर लेंथ 1 मीटर है तो सेंटर ऑफ मास हाफ, लेंथ 2 मीटर है तो सेंटर ऑफ मास 1, लेंथ 4 मीटर है तो सेंटर ऑफ मास 2। तो दैट्स व्हाट आई मेंट। और लेंथ चेंज होना मतलब मास भी चेंज होना। दैट्स व्हाट आई मेंट। ठीक है, ऑसम, बढ़िया, वेरी गुड। चलो फिर आगे चलते हैं, बाकी को अनम्यूट करते हैं। ठीक है, यस यस, सबका नंबर आएगा, सबका नंबर। थोड़ा सा आराम से शांत हो जाओ। हाँ, क्या क्या 42 पे आ गए, बोलो। यार तुमने कभी वो कछुआ छाप अगरबत्ती देखी है मॉडलिंग देखी है? तो सोचो वैसे ही मैं अगर रिंग्स रखता चला जाऊं, सबसे अंदर छोटी रिंग पे बड़ी रिंग पे बड़ी रिंग पे बड़ी रिंग। अनियन सबसे अच्छा एग्जांपल दिया था हृदय ने। जो अनियन होता है उसके रिंग्स काटो, रिंग मतलब अनियन के पोर्शन स्लाइसेस काट लो, तो हर एक रिंग अंदर दिखाई देती है। वो रिंग हमारा एलिमेंटल मास है, वो हमारा बिस्किट है। तो अगर सर्कल, अगर रिंग पूरी डिस्क सर्कुलर है तो पूरा रिंग, अगर सेमी सर्कुलर डिस्क है तो सेमी सर्कुलर रिंग। ओके, प्लीज शो अनियन मतलब सिद्धार्थ गौतम। मैं लिटरली अगर अभी तुम मेरे सामने होते ना, लिटरली तुम थप्पड़ पड़ता मुझसे। हाँ, यस दैट्स वन। इमेजिनरी कॉन्सेप्ट है, इमेजिनरी कॉन्सेप्ट होगा क्या। अब आज जो पार्ट नहीं कर पाए वो ये था कि जब ये सॉलिड ऑब्जेक्ट्स मूव करते हैं तो इनका मोशन बड़ा कॉम्प्लिकेटेड होता है। तो इनके मोशन को स्टडी करने से ज्यादा आसान होता है सेंटर ऑफ मास का मोशन स्टडी करना, क्योंकि वो पॉइंट मास है। तो इसीलिए उसकी लोकेशन जानना बहुत जरूरी होता है किसी भी ऑब्जेक्ट में। इसलिए हम लोकेशन स्टडी कर रहे हैं। एक एग्जांपल देता हूं, थ्योरेटिकल नहीं प्रैक्टिकल भी है, लेकिन वो लोकेशन मतलब सेंटर ऑफ मास पे पूरा मास रखा हुआ नहीं है, लेकिन उसकी एक्जिस्टेंस है। उसकी वजह से पूरा मोशन इजी हो जाता है। एग्जांपल देता हूं, स्पेस में कोई भी मान लो ऑब्जेक्ट है। तुमने वो मूवी देखी है ग्रेविटी? ग्रेविटी करके मूवी है जिसमें तुम्हारे एस्ट्रोनॉट जो है वो हबल टेलीस्कोप को ठीक कर रहे हैं। ठीक है, अब उसमें क्या होता है, एक एक एस्ट्रोनॉट जो है उसको किसी तरीके से कुछ हो जाता है जिस वजह से वो बैलेंस खो देता है। और बैलेंस खो देने के बाद में उसकी पूरी बॉडी ऐसे रोटेट करना शुरू कर देती है। ठीक है, तो वो जो रोटेशन होता है ना, उसमें एक्सेस ऑफ रोटेशन एक पॉइंट से पास होगी हमेशा। इवन बेटर एग्जांपल, कभी पेन फाइल का गेम खेला है जिसमें पेन रख के तो पेन जिस पॉइंट के अबाउट घूमता है वो सेंटर ऑफ मास है। तो पेन का मोशन एक्चुअली बहुत कॉम्प्लिकेटेड होता है, वो सर्कल में भी घूम रहा है और वो आगे भी जा रहा है। लेकिन हाँ, वो कुछ कभी भी वो घूमेगा तो सेंटर ऑफ मास के अबाउट घूमेगा। पॉइंट इज पेन का मोशन बहुत कॉम्प्लिकेटेड होता है। तुम पेन के मोशन को स्टडी नहीं कर पाते हो, लेकिन उसके सेंटर ऑफ मास को बहुत आसानी से स्टडी कर पाते हो। दैट इज व्हाट विल फॉलो फ्रॉम हियर आफ्टर दिस चैप्टर। ठीक है, चलो बहुत। अरे यार लगता है बहुत मुश्किल लगता है। ठीक है तो अच्छी बात है। ना ना, आगे ये समझ में आ गया तो चीजें इजी लगेंगी। तो ये होता है, वो बोलते हैं ना एक स्पीड ब्रेकर आता है बीच में, तो स्पीड ब्रेकर का होना जरूरी है, स्पीड ब्रेकर का। ठीक है, ओके गुड नाइट। देखो यार, पहली चीज ग्राउंड रूल सेट कर देता हूँ। मैं सबको एक साथ अनम्यूट नहीं कर सकता, ये बात सबको पता है। मैं सबके डाउट एक साथ आंसर नहीं कर सकता, सबको पता है। सो प्लीज डू नॉट ट्राई टू जस्ट कीप ऑन कॉपी पेस्टिंग योर डाउट। ओके, चलो भाई शुभात्मन से बात करते हैं। यस शुभात्मन। तो ऑडिबल ऐसा लग रहा है कि माइक से 1 किलोमीटर दूर हो। व्हाट? व्हाई कुड यू नॉट multiply this 1 with this 3 minus 3 k cap? What will you get? Tell me. Minus 3 k cap you will get? Yes? आ गया समझ में? Cool. Okay. Yes, we have. Yes, you are. Tell me. अरे पूछना यार। पूछो पूछो। हम्म, बस ऐसा नहीं कि डिफिकल्टी आना नॉर्मल है तो अभी सॉल्व करना बंद कर दो। फाइट मारते रहना। हम्म, मैंने मैक्सिमम मिनिमम बताया मैंने। जब पोटेंशियल एनर्जी से पढ़ा था हमने, वर्क पर एनर्जी में, वहां समझाया मैंने मैक्सिमम मिनिमम। स्पेसिफिकली बोला था कि मैं मैक्सिमम मिनिमम नहीं पढ़ाया था। वही है। और फिलहाल के लिए मैक्सिमम मिनिमम छोड़ भी दोगे तो नहीं होगा। फिलहाल के लिए मैक्सिमम मिनिमम नहीं भी करोगे तो कोई फर्क नहीं पड़ेगा, क्योंकि मैक्सिमम मिनिमम का एप्लीकेशन सिर्फ उतना ही है हमें 11 स्टैंडर्ड में, जो हमने वर्क पर एनर्जी में देखा। फिर कभी आएगा तो फिर से कर लेंगे, बट फिलहाल के लिए उसकी टेंशन नहीं लो। ओके, गॉन। आवाज क्या होगी? हाँ छोड़ दो, कोई दिक्कत नहीं, जितने होते हैं उतने कर लो। सिंपल सा फंडा है। अगर y इज इक्वल टू fx एक फंक्शन दिया है तो dy बाई dx एट मैक्सिमम एंड मिनिमम 0 होता है। अगर डबल डिफरेंशिएशन किया d2y पे dx स्क्वायर किया और ये लेस देन 0 आया तो मैक्सिमम होगा। अगर d2y बाई dx स्क्वायर ग्रेटर देन 0 आया तो मिनिमम होगा। यही चीजें हमने पोटेंशियल एनर्जी के फॉर्म में की थी। बस यही स्टेप फॉलो करो, सारे क्वेश्चन अप्लाई करो, हो जाएंगे। सेंटर ऑफ मास नहीं है, सेंटर ऑफ मास नहीं है, सेंटर ऑफ ग्रेविटी तुम बैलेंस कर पाओगे नहीं कर पाओगे वो स्ट्रेंथ पे डिपेंड करने लगेगा। सेंटर ऑफ मास नहीं है, सेंटर ऑफ मास इज नॉट बैलेंसिंग एन ऑब्जेक्ट, यही मैं समझाने की कोशिश कर रहा था अभी राजकुमार को। सेंटर ऑफ मास इज नॉट ट्राइंग टू बैलेंस एन ऑब्जेक्ट, फिर तो मैं रिंग को कभी बैलेंस ही नहीं कर पाऊंगा, है ना, क्योंकि उसका सेंटर ऑफ मास बाहर है। पर कहने का मतलब ये है कि जब वो ऑब्जेक्ट मूव करता है, स्पेशली जब वो रोटेट करता है, तो वो एक्सिस ऑफ रोटेशन हमेशा सेंटर ऑफ मास से पास होती है, एक फ्रीली जब वो मूव करता है। तो इसीलिए हम सेंटर ऑफ मास स्टडी भी कर रहे हैं, टू बी वेरी ऑनेस्ट। हम क्यों स्टडी कर रहे हैं, क्योंकि आगे जाके रोटेशन मोशन वाला बहुत सब कुछ जो है वो सेंटर ऑफ मास पे डिपेंड करने लगेगा। हां, लाइक अ स्पिनिंग टॉप, यस। बहुत सिंपल है, सर्कुलर मोशन मैंने बोला भी था, वहां भी बोला था जब सर्कुलर मोशन स्टार्ट किया था कि अगर मैं अर्थ का रेवोल्यूशन अबाउट सन स्टडी करता हूं तो अर्थ बहुत छोटा ऑब्जेक्ट है इन कंपैरिजन टू द रेडियस ऑफ द सर्कल ऑफ अर्थ मूविंग अराउंड सन। तो अर्थ को मैं पॉइंट मास मान के उसको सर्कुलर मोशन बोल सकता हूं, लेकिन अर्थ का खुद का मोशन अबाउट इट्स ओन एक्सिस इज नॉट सर्कुलर, दैट्स रोटेशन मोशन। क्योंकि अर्थ, अब मैं बोल सकता हूं कि अर्थ इज मेड अप ऑफ स्मॉल स्मॉल पॉइंट मासेस, और उन सब का मोशन जब अर्थ घूमती है तो सर्कुलर होता है। तो उन सारे सर्कुलर मोशंस का कॉम्बिनेशन रोटेशन मोशन है, रिजिड बॉडी का मोशन बोलते हैं उसे। ओके, हां अंश, ना सेंटर ऑफ मास इज ऑलवेज कंसीडर्ड एज अ पॉइंट मास, ठीक है यार। हां नहीं, क्या पता नहीं, मेरा यूजुअली डिनर आफ्टर द क्लास होता है। नो नो नो, डोंट हैव टू बी। ओके, चलो बाय बाय, गुड नाइट। Time for, is Hannah here? Hannah बोल रही है sir, basically I wanted to ask if we will get questions regarding center of mass of huge objects like star and planet, or it will be in rotation motion since they are in motion. We will not get questions about stars and planets 99.99%। जे एडवांस पूछ ले तो पता नहीं, बट हमें कोई क्वेश्चन सॉल्विंग के दौरान नहीं मिलेगा, है ना। ओके, है ना। अंश झा से बात करेंगे अब हम। नहीं यार, अमन आदित्य से बात करनी थी, उसने कुछ तो बोला था और वो आंसर नहीं मिला था उसे। उसके बाद अंश का नंबर है। यस अमन, गुड इवनिंग अमन। वो इंटीग्रेशन वाली की बात कर रहे हो ना तुम, जैसे हमने यहाँ पे इंटीग्रेट किया इधर पे, तो इस इंटीग्रेशन में हम लोगों ने लिया 0 to r, ये वाला या रॉड वाला। तो ये 0 इसलिए लिया कि तुम बिस्किट थ्योरी समझे थोड़ी सी भी। तो यहाँ पे बिस्किट कैसे हैं, रिंग के फॉर्म में है। सबसे छोटी रिंग कहाँ रखी जाएगी, टेंडिंग टू 0 हो जाएगा, तो हम उसे 0 ले लेते हैं। इसीलिए लिमिट, हाँ इसीलिए लिमिट स्टार्ट्स विद 0 इन दिस केस, क्योंकि अगर तुम इस पे भी आओ ना, ये वाला जो अपना रॉड वाला जो एग्जांपल था, यहाँ पे अपन ने 0 से l रखा था, तो जो पहला ऑब्जेक्ट है उसकी लोकेशन भी 0 है, उसका साइज 0 नहीं है, उसका साइज 0 नहीं है। लेकिन जब हम ये वाले एग्जांपल पे आ गए ना डिस्क वाले पे, तो लोकेशन 0 है सबसे छोटी रिंग की, और सबसे बाहर वाली रिंग की लोकेशन आ है, और उसके साथ में ना रिंग का रेडियस भी चेंज हो रहा है। मतलब ये एक्चुअली कॉम्प्लिकेटेड केस हुआ जहाँ पे बिस्किट का साइज भी बढ़ रहा है और बिस्किट की लोकेशन भी बदल रही है। सबसे छोटा बिस्किट का साइज भी सबसे छोटा, उसकी लोकेशन भी सेंटर। सबसे बड़े बिस्किट का साइज भी कैपिटल आर रेडियस का, और उसकी लोकेशन भी कैपिटल आर वाले सर्कमफेरेंस पे। सिर्फ लोकेशन x से आर 0 से आ गई, लेकिन साइज ऑफ ईच बिस्किट वाज सेम, 0 भी आया, एग्जैक्टली वही। इंटीग्रेशन में ऐसा करते हैं, ऐसा मान के चलो अभी के लिए, है ना। जब मैथ्स में तुम इंटीग्रेशन सीखोगे अगले साल, तो यू विल गेट इवन बेटर फील ऑफ इंटीग्रेशन। है भी वो, हाँ एक बार और रिप्ले देख लेना तो एकदम परफेक्ट हो जाएगा, है ना। ठीक है, चलो बाय, गुड नाइट। अमन झा किधर हो तुम, उसके बाद शिवांश का नंबर है। अमन झा किधर है, अंश झा, सॉरी अमन आदित्य था। ओके ओके, है ना, थैंक यू। अंश झा, अरे रुको यार, अंश को अनम्यूट करने दो तुम लोग, चैट पे इतना लिखो मत। हाँ अंश, हेलो बोलो। नहीं जरूरी नहीं है, वो बताएगा सवाल। लेकिन जैसे अब ये ऑब्जेक्ट, अभी हमने जैसा क्वेश्चन सॉल्व किया यहाँ पे अगर क्वेश्चन ओ को कहीं और डिफाइन कर देता, अगर मान लो ओ यहाँ डिफाइन हो जाता नीचे, ठीक है, तो फिर मेरे सारी चीजें बदल जाती। फिर इसके लोकेशन और सेंटर ऑफ मास को पता लगाना पड़ता, इसके सेंटर ऑफ मास का लोकेशन पता लगाना पड़ता, विद रिस्पेक्ट टू ओ पता लगाना पड़ता। फिर ओ देने का मतलब ही ओरिजिन होगा हमेशा, वो होगा ही रेफरेंस पॉइंट हमेशा ओरिजिन। और हम हमेशा चाहेंगे कि सबसे इजीएस्ट पॉइंट हम ओरिजिन ले लें, जहां से सारे मेजरमेंट जो है वो इजीली पता हो मुझे, हमेशा ऐसा कुछ करेंगे। तो हम चूज कर सकते हैं। लेकिन होता क्या है, जिस एग्जाम की हम तैयारी कर रहे हैं उसमें ऑब्जेक्टिव ऑप्शंस होते हैं, तो क्वेश्चन बताएगा कि ओरिजिन कहां है या कहां लेना चाहिए, वरना वो हमें ऑप्शन किस बेसिस पे पूछेगा, क्योंकि आंसर अगर मैं अपनी मर्जी से ओरिजिन चूज करूंगा तो सबके आंसर अलग अलग आएंगे। इसलिए उनको बताना ही पड़ता है कि कहां पे ओरिजिन है, ठीक है। डन, ओके चलो। नेक्स्ट वाज, हु वाज नेक्स्ट? नेक्स्ट वाज शिवांश। यस यस बच्चा, टेल मी। गुड इवनिंग। 12 पे तुम्हें भी डाउट है? ओके ये रहा, आ जाओ बोलो। इमेजिन करते हैं कि एक मासलेस रॉड पे रखा है, नहीं भी रखा है तो उससे सेंटर ऑफ मास कोई फर्क नहीं पड़ता, तो फिर x1 की वैल्यू 0 हो जाएगी, सेंटर ऑफ मास की लोकेशन भी फिर नहीं आएगी क्योंकि ओरिजिन चेंज हो गया, क्योंकि लोकेशन है ना। रिपीट अगेन, क्या बोला? सेंटर ऑफ मास जो होता है वो बेसिकली पूरे मासेस का एडिशन होता है। मतलब यहाँ m1 और m2 जो है, जहां भी सेंटर ऑफ मास रखा होगा वहां पे टोटल मास m1 प्लस m2 माना जाएगा, पॉइंट मास के फॉर्म में। और जो हम पता लगा रहे हैं x y और z, वो उसकी लोकेशन है। नहीं, फिर ये सिचुएशन आएगी जो मैंने बताई थी। अगर सेंटर ऑफ मास को ओरिजिन पे है तो एक मास राइट है और एक मास लेफ्ट पे है, तो तुमको देखो यहाँ पे ये -x1 बन गया, ये x2 हो गया, सेंटर ऑफ मास 0 आ गया, रादर सेंटर ऑफ मास की लोकेशन 0 आ गई। दैट विल बी कंसीडर्ड एज वन ऑफ द मास ऑफ द सिस्टम ना। अगर एक और मास रख दूं यहाँ पे m3, तो फिर उसको भी लिखना पड़ेगा मुझे यहाँ पे m3 × 0, और नीचे डिनोमिनेटर में प्लस m3 भी डालना पड़ेगा। ये बैलेंस हुआ नहीं था, मैंने बैलेंसिंग पॉइंट पे ही मेरी पॉइंट ऑफ ओरिजिन डाल दी, ओरिजिन मैंने मेरे सेंटर ऑफ मास पे मान लिया। हाँ, सेंटर ऑफ मास का लोकेशन नहीं बिगड़ेगा, चेंज नहीं होगा। हाँ बिल्कुल। वो क्यों नहीं बिगड़ेगा? क्योंकि तुम यहाँ लिखोगे m3 × 0 प्लस m3 लिखोगे यहाँ डिनोमिनेटर में, ये पूरा डिनोमिनेटर जाके 0 से मल्टीप्लाई हो गया, और m3 ऑलरेडी 0 से मल्टीप्लाई हो गया, तो कहीं कुछ इंपैक्ट आया नहीं इसलिए। हाँ, अगर यही चीज यहाँ से चल रही होती, पिछले वाले सिनेरियो पे चल रही होती, तो लोकेशन बदल जाएगी सेंटर ऑफ मास की। मतलब एक्चुअल में सेंटर ऑफ मास 3 मासेस का जहां है वहीं होगा, लेकिन तुम कहां से देख रहे हो, तुम मेजर कहां से कर रहे हो, उस पर डिपेंड करेगा, ऐसा बोलना पड़ता है। सेंटर ऑफ मास की लोकेशन है ये, सेंटर ऑफ मास की डिस्टेंस हम पता लगा रहे हैं, ये बात क्लियरली समझना, ठीक है? ओके, और कोई है? आर वी डन? Sir, by the way, Tattva does not emphasize on the first part you discussed. That's okay. You are in my class. Now emphasis is there, right? So Tattva के वैसे भी मैं Tattva से theory पढ़ना recommend नहीं करता. It does on the shape of the bodies. Absolutely. Center of mass depends on the shape of the bodies. क्योंकि वो distribution of the mass पे depend कर रहा है. Distribution ही change हो जाएगा, shape change हो गई तो. अगर मैंने rod को bend कर दिया तो center of mass का location बदला ना? अरे absolutely यार निहाल. Yes, sir. Tell me. Slide number 36 is here. हाँ. बोलो. That's called mass per unit length. That's called density. That's called linear mass density. That's the same thing. It's the same thing. Because it is mass per unit length and is also mass per unit length. Have you ever seen a Rubik's Cube? For the Rubik's Cube, the entire mass is capital M, its volume is V, right? If I only talk about a single cube in the Rubik's Cube, its mass will be small m, its volume will also be small v. Can I say these two will be equal? Do you understand the concept of density? Do you understand the concept of density? Its mass per unit volume means what? If I will take a cube and I will cut it into exact half, mass will become half and half, the volume will also become half and half. What will not change is the ratio of mass and volume. That's called density. That's called packing of mass in a given space. How mass is packed in a given volume. So that value of packing is found as density mass upon volume for a normal 3D object. But if you speak about a 2D object like pizza, if you cut pizza into half, this half and that half will definitely have same area, will definitely have same mass m by 2 m by 2, but will also have the same value of mass upon area. But if you divide the pizza into unequal slices, then also their mass definitely will not be same. All the pieces, their areas will not be same. But what will be same is mass upon area. Similarly for rod, if you break the rod into unequal pieces, the each piece will have different mass, each piece will have different length. But what will be same for each piece? The mass per unit length. That is why we have equated these two here. This is mass per unit length for the entire rod. This is mass per unit length for only the smallest of the portion of the rod. That's the beauty of density, by the way. One of the most important things today, yeah. Can I not say that every rod is more or less like it has to be seen like a scale. It has to be seen like a scale. So when I bend a scale, the scale will have some width also, right? When it is bent like this, right? So that is why the width is also spoken about. The width of the scale is dr. The length is 2 pi r. Sorry, in this case pi r. That's why the area is length into breadth. The rectangle bent into the form of a semicircular portion. The semicircular portion I can't find the area, so I converted it into a rectangle. Got it? Hmm. Hmm. Mm-hmm. No, it will not. It will not. It comes to me only when there are CTs in the class, and there are no CTs right now in the class. When they forward to me, then only it comes to me, and not to any other student. So next time maybe you can ask the CT while typing to forward it to me. Nothing. Okay. Vishesh, I do not have any tips for KVPY. For that, I have only one suggestion. There is a parallel KVPY course which is going on. You can be in that. Okay. that's really nice, Samarvida. So nice of you. Very kind of you. So then, Vishesh, those teachers are actually the right teachers to guide you. Okay. I'm actually not the right person to guide KVPY, and more or less because I have not prepared in my life for KVPY. That's why. So I don't hold any experience, and I've never taught anybody for KVPY. That is why, zero experience. Doesn't matter, Sayesh. Sayesh, doesn't matter. Okay, everyone, new song. What song? What song? Been a long time, never played. Sir, when is your guidance session? I don't know, Samarpita. They placed it and they removed it. It was supposed to happen today, right? Didn't happen. But I'm giving you guys guidance every time after the class. Khatika, I will play. Don't worry, but not today. I'll play it someday. Don't worry. Okay. जिस दिन रोटेशन मोशन कंप्लीट करेंगे ना उस दिन प्ले करूंगा. ठीक है. अरे YouTube पे अलग बात है यार. YouTube के मेरे स्टूडेंट्स बहुत पुराने हो गए. उन्होंने रोटेशन पढ़ लिया मुझसे. We'll see that, Vishesh. We'll see. ठीक है, बच्चा पार्टी. Close to 11 o'clock. Let's wrap it up now. We'll meet again next time. Till then, do watch the replay. See you all next time. Up to you, Nihal. Chalo. Bye, guys. Hasta la vista. Yes. Chalo then. Good night. Signing off. See you all next time.